Good morning, everyone. Welcome to MC 1303 bone-based facial rigging. Today we're going to try and explain and sort of have a look at different ways of approaching facial rigging and what can be used for in this particular method. There's really two sort of main ways that facial rigging is done, and that would be morphs, so morph targets using morpher, and another is bones. And another is a completely hybrid system, really, where you're using both. And this guy's actually a good example of that, sort of both. But we're going to be able to have some of the sort of bone-based idea behind it in the rig that we're going to do today. So the idea of facial rigging in itself is one thing it's definitely an art form. It's definitely something that needs to be worked on and understood. It isn't just about, like anything, getting the face to sort of move and pose. It's how it poses and how well it gets in and out of poses, how smooth and natural it looks. Even on a cartoony character like Dave here, and I'm sure you guys have seen Dave on the Autodesk little short film that helped work on for those guys. So this was Dave, and Dave's got a relatively extensive face for the most part for what was needed, I guess, but it allowed for a lot of flexibility. It's nothing really overly fancy. It's pretty much bone-based as far as the jaw goes and as far as a bunch of these control points. So you see those control points sliding around on the face right now. And the way I went actually about doing this one, and have been doing it for years, I'm not going to show you because, quite frankly, I've found, I think, is a better way, which I've just, certainly a faster way to calculate. How's that? And allows for the same kind of control. And like anything, a bunch of Max script is going to help make it faster. So what it does allow is, in this case, you can see that we can make the character smile here and pull the corner up. We've got a typical floating UI that you may have seen on the internet in facial rigs. It also gives us the ability to be able to pull on and deal with poses for different parts of the character. I got some crashing that happens, but that's okay because at any point in time, animators can go and grab any one of the controls or sets of controls and manipulate any of those controls individually as well. So what we can basically have is some presets and some and shapes and forms and whatnot built, and then you're able to go and animate these and do whatever you want with them to get the kinds of poses that you're looking for. This can add a lot of flexibility to the face for the animator. Part of the problem with morph target, sort of a straight up morph target based face, is that you get what you get. And you try and blend together targets, but it's very difficult for the animator just to go in and say, hey, I want to grab this lip and I want to pull on it. So bone-based facial rigs aren't just for game scenarios where you don't want to be outputting morph targets because they're very expensive in as far as it goes for a game engine. They're also used a lot in feature film and whatnot where the animators want to have a lot of good shapes to start with, the big forms and shapes to start with, but then the ability just to be able to manipulate the face any way they want, to be able to grab any targets they want and work with it. We've got the brows right now just sort of up and down, and I've got outside up and down, the inside up and down, but they can then go and overlap timing and work with timing on top of it and do whatever else they need. Again, flexibility for an animator is the key here. And what you're looking at also has a number of controls, which basically there's a bone strung between each and every single one of these right now. If we were to take a look at the rig, you'll see all these lines. They should be, oh, you know what, they're not actually bones in this rig, but it doesn't matter. Bones are just nodes in Max anyways. So each of these blue lines represents essentially a bone that's been skinned to. And stuck around the surface. Now this is probably a lot for most gaming environments that you'd be using. Some games have gone a long way for a lot of really good facial rigging when it comes to being able to sell the game, but and sort of whether it be cutscenes or whatever else. Most aren't using this many. They may only have a handful around their face just so they can open their mouth and kind of make some expressions and whatnot. What we're going to sort of discuss is, the sort of closer to the higher end of it, and then you can dumb it down or add on to it, somewhere in between. Now this rig uses actually morph targets and bones to work with it. And again, we're not going to go that way. We're not going to go that route. So we're going to take a look at another solution that I've come up with. So this is one that I've just started using. So what I'm doing is I'm showing you tech. I mean, there's a big thread on CG Talk recently of TDs not showing what they do, or at least not what they currently do, and that's never been the case of myself. I don't mind sharing what I do. So let's get into it and start taking a look at how we set this up and how we put these controls in here and how we do it quickly. That's one of the keys. This can be time consuming, as is morph targets, but it can be very time consuming and very slow, laborious process if you don't do a little bit of Max script around it to make it work better. So everybody can see this stripped down Dave, I guess. And this stripped down Dave has got a little bit of rigging set up on it so far. So what I've got, just to start with, and the way I usually start it, I don't know if you can see the current rig that's in the back here. Oops. Oh, that's right. I've got some point helpers that are flying off everywhere. These bones basically would sort of represent the neck that's been set up. So right now I've just got to, I've cut the head off to make it simpler to show for this class. A couple bones that up through the neck, one big one for the head, one for the jaw to start with. And what I've done is I've done some basic skinning. So to get started, what I've done is I've skinned the character up so that we've got first bone, second bone up into the neck, wrapping around, getting a bit of a smooth blend. It's not very good. I literally did this in about 5 minutes this morning. One around the face that's handling sort of all the areas that shouldn't move with the head, which would be sort of solid for the most part. So it's handling that. And then I put in a jawbone. And I basically try and blend up the jawbone into the neck's not very good right now, but I'm not concerned with down there for this class. And I've set up one for the jaw that just opens the jaw at the right pivot, so up where the pivot is. And I've blended it up into the up into the head for now, just sort of reasonably well to get started. Now what's going to happen is, because we're doing bone-based rigging, it's all going to be skinned, and essentially most of everything around the mouth, certainly around the eyes and whatnot that we're doing right now, it's all going to be overridden by some new skinning. So what I'd find though is I like to do my skinning bit by bit. I would never sort of go and skin this character by creating the main rig, creating the entire facial rig, have a pile of bones everywhere, add them all at once, and then try and skin them all at once. For me, I find that a much slower process to get right, and I like to think of things as sort of a layered step approach and do one step after another. Even though most of this is going to get overridden, I like to see it work, and it took me all of a couple of minutes to get it to work just by painting in some weights and doing some blended weights around the corners of the mouth just to get it all working. Part of the reason being is that I know what's being affected by what. Certainly one of the things you want to do is go into vertex mode and make sure that, certainly if you're paint weighting, don't just jump into paint weights with skin. One of the first things you should always do once you've finished setting up envelopes, which I did very little of. If you look at the envelopes on these envelopes here, you can see they're pretty rough. They're just dropped in. They were very wrong to get started, and it took a lot of weighting, hand weighting. I use the weight tool a lot, so you're going to want to take a look at that if you haven't used it for skinning. I use it an enormous amount for getting things like the jaw done. All I do is grab that bottom bone, grab a vertex in the middle, grow it a bunch, and then hit 1. Next thing you want to do is you want to always make sure you remove zero weights, and make sure that any weighting that shouldn't be there, a very low amount, 0.01, is removed. Idea being is this: you want to make sure that it's very clean, this skinning, and you know what is skinned to which bone in this case. Because as soon as we introduce a whole bunch of facial bones to this system, it's going to be a real problem to keep smoothing and make it work if we've got all sorts of bones. You know, if this neck bone back here was influencing, vertices up in the front of the jaw by mistake, every single time we would blend weights, it'd blend weight back into this neck bone, and that isn't what we want. So I want to make sure it's really, really clean and, working as sort of best as possible, and I know what's going where. So that's very important when I'm working. I'm just going to say show no envelopes again on the rig here. And what we're going to do is we're going to start looking at how we're going to lay out this face and how it's going to move and act. This is a big face, and it's kind of the reason I picked this one, is that he's got a really big poses we want to be able to get. You know, if we look back at his mouth being able to open, it can open a long way. Forget where it is, and there's jaw down. In the original here, I even had the ability to be able to drop the jaw entirely, so he can just make a huge mouth. So I'm actually doing something you can't do, and I'm taking the whole jawbone and I'm just moving it up and down. You know, so you could have done this. You can see the jawbone in the mouth here moving up and down. It can also move forward and backwards. So again, being a cartoony character, you want to have a huge amount of play in it, and just have it be able to be just, completely manipulable. Number one thing I find that new technical directors want to do is they want to try and limit controls for animators, and make sure, for instance, an elbow doesn't rotate too far, doesn't rotate backwards. Animators will hate you for that, without question. They want to just unlock everything. The current rig I just did, they wanted to be able to move and rotate every joint in the body, even if that joint isn't supposedly able to move and rotate, and scale, by the way. So everything they needed to be able to move, rotate, and scale for them to get the motion that they wanted. They didn't want to run into a position where they suddenly couldn't do something. And that's especially true for cartoony characters. So what we want to do is we want to start setting up bones around this character and laying them out so we can figure out how we're going to manipulate it. Now, we're definitely going to need some around the mouth. And we want to be able to, curl the lips up. We want to be able to curl the lips out. If you think of a big pouting bottom lip that's going on. Again, we've got that somewhere in here as well. I think if I do transform to 0, there's a big pouty one. Somewhere lip curl, I think it is. So he's got this big pouty bottom lip. And he can do, I think, a pouty top lip too or something somewhere in here. I don't know where they all are anymore. It's been a while since I've been in this one. And we want to be able to get things like this. So we need to be able to also rotate these bones. You can see that the bone controls have rotated out, so that we can really, really, really get some neat shapes and forms out of it. We're going to want something around cheeks. We're going to be able to puff the cheeks and get a nice round shape for the cheeks, up and around the eyebrows. One of the number one areas of a character that is often forgotten, again, when I see in sort of new rigs, is the eyebrows. They always say the eyes are the windows to the soul, but it's really not the eyes so much. It's the eyebrows. And if you think about, when you're looking at some of the great cartoony characters out there, they always have big brows, and they're able to get nice big S shapes out of the brows, nice big bold shapes. The eyes might be what you're looking at, but if you look in the mirror and sit there and frown and crank your eyebrows up and down, you don't even have to do much with your eyes. If you can just do it with your eyebrows, or even just draw it like that, leave the eyes as they are, don't open or close them, and just change brow shapes, you'll suddenly notice that the overall feeling of the character changes greatly. You don't even have to change the mouth. So we really want to make sure that the brows have got that really solid control system in them. So let's start laying down some controls. Now, here's the problem. What we want to have is sort of a layered bunch of controls. Now, I'm just going to run a script here off to the side before I show it to you. Hang on one second. It just drive is booting up. There we go. And I'll show you what I mean by it. I'm just going to go and create a control object here. And I'm just going to say yes. And you see that I've got ones on both sides, essentially. So what I've got is a control object for the mouth here. I've got 2 point helpers. And I'll explain how I made this in a second. So here's the control object. It's a circle. It's going to be a way for the animator to be able to grab and manipulate it. It's parented up to a large point helper, which is parented down to a small point helper. Now there's reasoning for this, believe it or not. Our sort of UI, our floating UI that we're going to build, is going to have control over this large point helper. Okay, it's going to actually be able to manipulate this one. And if you notice, the control object is going with it, the big blue control object here. Maybe I should just turn this guy gray. There we go, that might look better. So when this large green point helper moves, you can see that the blue one, the blue control object goes with it. This is how we're going to actually set it up so that we're going to be able to manipulate a floating UI and have it look like the control objects are moving along and sticking to the face. And then the animator will be able to grab these control objects and offset from that point. Do you guys see where I'm going with this? Okay, here's one of these areas that we can actually speed up the process a lot. I'm just going to delete those for now. And we're going to start looking at some Max.Script. Let's forget this Make Bones tool for the moment that I was just trying to look at. How many people here have written any Max.Script? Hands up. Some. That's good, Mark. Little. Good, David. That's fine. We'll get you through the hump. The other guys? Very little. All right. Not yet. Okay, CK. Well, you're going to have to. It's again, in my opinion, and Eric, I think it's a yes for you, isn't it? In my opinion, you just can't be a technical director without Max.Script. You can't be rigging characters. You can, certainly. What I'm about to show you, you could do it completely by hand, and it would take you forever to really do effectively and well. It would be a very slow process. So what you could be doing is you could easily be creating point helpers, and we can easily do a couple of things. We can actually say snap, so a very manual way would be able to say, let's snap to faces, and turn on our snap so I can snap to faces. I could then say create helper's point, and I could go along and I could drop a point helper where I want. I would then have to go through the process of rotating it around so it points in the directions that I want for each one of them, and we want them all about the same sort of thing. We want Z out and X across and Y up. And we'd have to sit there and move them around until we got them on the in the right spots. Then we'd have to figure out how to get them on the other side. Now, getting them on the other side, if you don't know about this, we can actually just go into my scripts. And again, we've got mirror objects. And if you use my mirror objects tool here and download it, you can easily have it make mirror objects. Note, if it's creating, you got one selected and it creates you copies or instance or references, hierarchies will not be rebuilt for you. I never got around to putting that in this one. The mirror tool here works by selecting pairs. So if you select two objects and hit mirror, it'll take the data from the first one and mirror that data over to the second one. So that can be pretty handy, but again, I think you can see that it would be a really slow process because I'd have to go in and say rigging, mirror objects, and I'd say flip it around the Z. We don't want to do that. We want to flip the X in this case. And I'm going to say create on the other side. So creates it on the other side. We'd have to do that for both point helpers on each side and both the control objects on each side of each one of them. And this would obviously get pretty slow. So the best thing to do is start doing a little bit of writing of Max.Script and create something that works. Now what I've got is a pretty small tool when you look at it here. It's got two main parts, sort of a run tool here. And it's got a make control, which makes all the point helpers and everything else. So what we're going to do is we're going to set that up and write that first and get it working. So I'm just going to start a new script and just make it large. Now, tools are best written when you, in my opinion, when you use structs. And a struct allows you to be able to sort of contain everything inside of a single sort of tool that you get access to. We're going to call this bone-based facial rig in this case. And we're going to be able to access everything inside of it via that name. So what we want to create now are a couple of things. First off is when you look at it, we want to be able to set the target node. So we're going to be able to target a node, and we want to be able to set that name. In this case, it's going to be this object here by its given name. But we're just going to make a variable inside of this struct and work with it from there. So this is just called target node. Items inside of a structure are separated by a comma. So at the end of any sort of section that we write, we're going to have to put a comma to make sure that each item in the struct has been separated with that comma in there. So there's our target node. We're going to be able to set that, in this case, to Dave's head here. Now the next thing I actually used is just sort of a preset in here to make sure that we could get different sizes and whatnot, was a little variable just called a control size. And this control size allows us to be able to put in a value before we run the tool as to how big each control should be made to begin with, just making it easier to more purposeful from one character to another. So I'm going to drop that one in as well. So we'll call it 2. I think when I was building on Dave there, it actually made them a little large. So let's actually just default it to 1. We could change that any way we want as we're working with it. But let's make sure we have a default of 1 on this. Now, let's just run down to the very bottom. The very, very bottom of our tool here, you'll see this line here. And we'll just go and copy and paste that. I'm just going to actually take the comma out. The last item in the struct shouldn't have a comma after it, by the way. Essentially, if you were to look at a struct, we'll call it variable, comma, some function, comma, whatever. That would be what the struct would look like if it would lay it out flat in a sense. So commas in between each one. So if I run this and evaluate the structure, one of the things you want to do is make sure that your listener is up. Let's make the font larger in there. I'm going to select all of the struct and push Shift Enter, which will run just that area. No nasty red bits. And it's basically give me a struct named bone-based facial rig. It says right now that there's 2 properties inside of it. They're going to contain data. And what we want to do to be able to run this is we actually have to make an instance of it. So we basically have to make a big copy of the structure. And what I'm doing is I'm just real easy. I'm just overwriting the name with itself. So if you actually run just this part here with the open close parentheses after it, it will run this structure. And it just made an instance of it. And we want to capture that instance in a name. So I'm just going to capture it back in its own name. So if I run that with Control E or Evaluate All up top here and run that, you'll notice that we've basically built a tool. And we can get access to that tool via any of the names. So I can go in and say bone-based facial rig dot target node and run that just with my mouse on the end of the line or anywhere on the line with Shift Enter again, and you'll see it says undefined. And that's because I've just set it to empty to begin with, just completely undefined. First thing we're going to want to do there is we're going to want to set it to whatever object we're currently going to be working on. So I'm going to grab the name of our monster. I'm going to say equals. Any object in Max is always prefixed with a $sign to say you're working with that object. I want to paste the name in. Let's just confirm this. I'm going to highlight the name with the $sign, run it. Again, no red. It gives me proper object back. And if I run this now and evaluate the whole script, I've actually just evaluated this line now. If I just evaluate the bone-based facial rig.target node again, what you'll find is, let me just clear the listener so you can see it better. It's returning that object. So I've actually just stored an instance of the object back into the structure for the structure to use and work with. Everybody good with that so far? Okay. More scripting classes, CK, and you'll follow it. What are you confused with, Stefan? Why a structure? It's a good coding practice to contain your tools into a local variable, essentially. This is the only thing right now that's global. If you just wrote all of this in a script, it means that everything is just available globally. It means any other Mac script that's running could overwrite our variables and cause errors and problems. Containing everything inside of here is going to allow us a tool that we're going to be able to dig in through the instance of it, get at, set the variables, but none of these variables will actually exist outside. If I actually pick target node and evaluate it, you'll see it comes up undefined. It's not a variable that's accessible from outside. No, you don't want to type this into the listener. You want to write a tool here and write it as a Mac script and go down this road. With a circle? I don't know what you mean by with a circle, Mark. Yes, this is the name of the mesh. Just copied and pasted it out of Max. So this is the name of this mesh that we're going to be trying to target and drops objects onto. So it's Monster Geo Monster Body 01 is the name of that object. Yes, I guess Stefan, are you talking about that and execute? Any one of these bits and pieces could be executed in the listener, but the whole tool, you don't want to be doing that. Yes, you could execute the struct inside the listener, but I wouldn't suggest writing your tool inside the listener because you're going to lose it pretty fast. You want to make yourself a tool that's reusable and easy to be run at any point in time and to be reused and reused and reused. Fair enough? Yes, you should always re-execute. If you're changing stuff in here, you should be re-executing the entire script and execute it. So that's under Tools, Evaluate All. Again, we can do line by line, and whenever you're writing, you want to check things line by line and make sure that each piece works. So I can highlight just the structure and go Shift Enter. No error messages. Whereas if I were to do something like just this piece, it's not even going to give me anything. So it's going to give me a big red error message here because it's not complete. It doesn't have the open close parentheses after it. So there's my structure working. So I can make an instance of that structure. I can set the node in that structure. Now I know that if I go Control E and run the whole thing, it should run. So essentially you want to be in a position where you can check each and every piece as you write. You guys good with that? You could write this all left justified without the structure with each function, but you're going to find that it gets messy over time as you start developing tools this way. David, I don't completely follow what you're saying, but yes, make sure you evaluate the whole thing. You guys good then? You can actually find a bunch of information about sort of coding practices on CG Talk, where we've had long, in-depth conversations about using structures to build good tools. And essentially, every single tool I've got is built inside of structures. If you look at this tool set here, this is my rigging tool set. What we've got is we've got tools all written individually that are all structure-based tools. And all of these things are running inside of structs. So it's a very, very good way of going about developing and working with your tools. So let's continue on. So what we need now is we need a way of being able to run some mouse tools, they're called. So when I go and click on an object and click on the screen, I want something to happen. And if we look over at my, just make it smaller again so we can see the whole thing. What I've done is I've created a function, which is just a tool that can be run, basically, inside of my structure. And I've called it run tool. I'm just going to copy this over. Whenever you're making parentheses to encapsulate something, make sure that you always first close it. Don't just start writing more. Make sure you're always closing them as you go so that you know what you've actually done. You can see that when you've got a closing, if you put your mouse inside it, it'll turn blue on you, and it'll actually highlight the closing one that comes after it. Now what this function is going to do is it's going to create a mouse tool called mouse hit for us. This tool, if you look up tools in Max.Script help, allow you to be able to track what your mouse is doing, track your mouse on screen, and track all of the button clicks that are happening as you work. So what I've first got is an event handler inside of this mouse tool, this tool that's happening here. And this is basically checking. It's saying on mouse point, so when the mouse is pointing on the screen and we click, how many clicks have we clicked? And we're going to count those. So let's just copy and paste this little piece inside of our tool. Close our parentheses. And I'm just going to use a little quick error checking, not even error checking, just a little statement to check and make sure that indeed something's working with it. And it's a print statement. A print will just print out click no. And click no is the click number. It's going to give us how many clicks we've clicked with our mouse in the screen. So let's run this now. If I evaluate the whole thing, check and make sure that we've got any errors, and we do. And the reason we got an error is we added a new function after our variable and we didn't put a comma in. So we can run it again, we can evaluate it, and now we've got a tool that's working. What we want to do is we want to run this function here. So I'm just going to copy my instance. And I'm just going to run the function inside of it. So now that I've got this, this tool working, I've set up that object on it, it's in there. I can run this line and watch what happens now. I run it, mouse tools is now running. We didn't fire it up. So the tool's there, sorry, we didn't fire it up. The last thing we need to do with the mouse tools is actually tell it to start and actually run. So we're going to do that just outside of the tool here. So we're going to make the tool. We're just going to check which mouse points we've clicked, and we're going to tell the tool to start. And I'm going to run that again, and you'll notice that my mouse pointer, I don't know if you can see it, it's a little crosshairs now. It's no longer my rotate tool. And if I click down, I've held down my mouse button, I get a value of 1. So it actually knows I've clicked down once. When I let go, it's 2. Interesting from here is down doesn't do anything anymore. I just click down again, and 3 is up. Down doesn't do anything, 4 is up. So it only registers the first click down on something. So as I click, you'll see it's actually counting now because it's doing print out the number of clicks that I've actually doing on the screen here. So you can see it's actually kicking out those numbers. Right click and it goes to an abort and kicks out the tool and stops it from running. So basically this tool is what's running when you go and make objects in Max. You know, when you make a box and you click and drag. Using mouse tools is how you actually go about doing that. So now that we've got the amount of clicks, we want to start doing something with them. And actually, essentially, we want to cast a ray. We want to fire a ray from our screen onto the surface of the mesh and find out where we're over top of. So when I click here and I go and click on the mesh and let go, I want to know where that point is on the mesh. I want to know which direction the normal sticks out of that polygon that I hit, exactly where I hit on that polygon. And I want to be able to stick a point helper there, or 2 point helpers in a control object, a circle. And I want to hook them all together and have them all nicely aligned up to that face for me in one good, quick shot. You guys following so far? See, when I say intermediate class, I really mean it. Are you okay, CK? Or have you timed out on us? Local axis? The objects are clicked. There is no such thing as a local axis, David. Realistically, there is no local axis. You're going to see how we're going to do it. We're going to make things all in world space. Local view means nothing. This is irrelevant, this information up here. The only thing that really exists is parent space. And again, if you come to my math class next week, you'll find out why. So we're going to do it all in transform matrices and in world space vector data. So we're going to do a little bit of math class today. that you really should come to next week if you want to know more about it, because it's the best way of going about doing this sort of thing is understanding a little bit of transform matrix stuff. So what we need to do is we need to get some of this information. Now, what you'll find is that I'm doing an if test here, and the if says if click no is greater than 1. So I only want to create points when I've released the mouse. So the first time I click down is 1. Everything else from that is up on the mouse. So I just want to make sure that I'm not making one on down and one on up. So I'm asking if click number is greater than 1 do. So I'm going to copy that over. Close my parentheses. So this should only register now. If I ran it, it shouldn't register 1. It should only register 2 and 3, 4, 5, 6 from there. So it's only taking the ups from this point on. Here's a command that we're going to need right off the bat. And what I'm going to do is I'm just going to say print R this time. So map screen to world ray. Mouse position. So mouse position is a way in MaxScript to find out what the position of the mouse is at any given point in time on your screen. So if I run that, you can actually see wherever the mouse was. If I move my mouse over here and run it, you'll see the numbers different. So it's actually checking wherever that mouse is. And I want to get this as far up into that corner as I can. Highlight that and run it. You'll see that I'm getting closer and closer over to this the side of the screen. So actually, I'm not even quite sure why I came up with a negative there. This is returning where the mouse is. Now, what this command is doing that's built into MaxScript is turning it into a ray. An array, I mean, if you guys are using mental ray or V-ray or anything like that, it's a ray. You can think of it as a little laser beam that's being cast into the scene. So what's happening is when I click, it's taking my mouse position, it's turning it into world, it's finding its space in world space for us. We don't even need to know how the math works for that because it does it for us. And it gives a little pointer from that point in space, pointing at the surface, and we can fire a ray at the surface, just like we would if we were doing ray casting in mental ray or V-ray or anything else, and fire a little ray at the object. So if we run this, and I just click on the surface, and I'll just end so we can take a look at what that ray looks like. So here's what that ray looks like. I'm just going to actually just copy that up to here so I don't lose it for now. So it has two parts. Array value has two parts. First off, the first part is a position value. So ray.position, or r.position in our case, would return this value here. And that's the position the mouse was in world space, basically above our object when we clicked. This value here is a vector. And the vector, if you notice, it's very small numbers. They're all under 1. This is what's referred to as a unit vector. So if you think about the old Cartesian graph, it's basically giving us a little dot out from the center of our Cartesian graph. So what I'm going to do is just quickly, I'm just going to turn on my So if you all go and do that with your right hand, so make one of the old, guns, but then take your middle finger and stick it perpendicular. I'm constantly moving the wrong way here. Perpendicular to your index finger, and do that. This point here at this knuckle, this is the position of our transform matrix or array that we can look at, basically. So we can look at this just as an array right now. There's our position point, and it's basically where that first value is, that position. At the tip of this finger, we're not using a rotation value or something. What we're using is just another little position point. So there's a little point at the end of our finger here, and that position point, okay, is 1 unit. Basically, it's 1 unit in length from the position to here. So that value is just 1 unit in length, and it just points out from the surface, and it basically says, fire the ray in this direction. Fire the ray from this position point through this little vector, and just continuing on up and through the scene until you hit something. Is that That make sense? Guys? Okay. I'll just turn that off again. So that little vector allows us to be able to fire it off in the right direction. Now what we're going to do is we're going to use the next command, which is called intersect ray. An intersect ray, again, is another command. You can see it coming up blue in here in Max.Script. And what it says is I'm going to take a ray. So this is our ray from our, and you see R being mimicked down at the next line. I'm going to fire a ray using that position and that direction vector, and I'm going to fire it at this object. And that object is being defined right here in our structure. So I'm saying intersect ray on this object, firing from this ray position and direction. And return a hit. And so let's just say print hit. And if I click, you'll see what it actually returns is another ray value. This time the ray value is the position in world space that it got hit on the surface, and the vector that's returned is the vector pointing out from the normal of the surface. So it's the Z direction, like the direction the normal points out from the surface, out from the point at which it hit the surface. So this is just another ray value. So what you've got now is you've got the ray that we firing out from this point here. It hit a surface over here, and it returned a ray that points out the other direction. There's the point that we hit at, and then another little vector at the end pointing in the direction that the normal goes at, whichever way that normal happens to be, hitting that surface. So it's returning a hit. Now what the hit's going to return is, if I run it, and you'll see it returned undefined there. Let me just, oops. What did I just do? There we go. Please tell me I didn't break something. There we go. Clear the listener. Sorry, Control D clears the listener. Fire that up again. Control E. And I'll just click off of it, and you see it returns undefined. So if I miss the mesh, I'll get undefined. If I hit the mesh, I'll get array. And so I'm just going to do a little quick bit of error checking, and that's when I hit the and actually make a control object. So let's actually go and make a control object. I have another function for making control objects. It's best to break up any Max.Script you write into little bite-sized pieces, okay, and not one gigantic chunk writing everything inside here that it's going to do. It makes it far easier to manage and work with and develop your tools. So I'm just going to go and create a new function above the old one, and comma after the end of it to break it up so that our tool works. Let me just run it, make sure we don't have any errors. Those are world space values in the ray, correct. This is the world space value that we hit the surface. This is a world space, or this is a sort of, this vector is in the space of this position. So it is a point offset from this position value. So this is not a world space sort of value. It is, in a sense, parented to this. So if you take that position, add that onto it, you'd have that little vector point out from the surface. Yes, you can do the difference between them if you wanted, but you don't even need to do that. The ray value, when you fire a ray, it knows to use that as a direction from this point. So it takes this point, starts the ray at this point, adds this onto this point, and fires it through that vector. You guys good with that? So basically, if you add this value to this one, you'll get the world space value of where that end of that point is. Well, in this case, we're firing from the screen space when we click, and it's returning a ray of where we hit and the direction the normal points out from that surface. No, there's no axes here. There's no X, Y, Z rotation values. No, we're using not even the normal of the camera. Yeah, I guess it's the normal of the camera that we're firing out from. Correct. We're firing out from the normal of the camera from wherever you click. So it's when you first click, it's firing it directly from your mouse straight down onto the surface of the mesh. And then the one that returns is the point on the mesh and the direction, the normal points on the surface where you clicked. So we're firing from one ray, and it's returning another that we're going to use to build our object and make sure it's pointing in the right direction. Okie doke. Now what I'm doing is a bit of hit testing. When I send this, I'm going to call this function now. So I'm going to call the function. So basically I've clicked down, I've created a ray from my mouse, I've hit the surface, I'm going to say make control, I'm going to pass that hit value, our ray, into this make control, and I'm just going to do a quick error check. If hit is not equal to undefined, it means I actually hit the mesh. Now let's go ahead and do something, and let's actually start building our model here and building what we're looking for. Now I'm just going to do print hit.pause, and I'm going to say print hit.dir. These are the two parts of this. This is the position, pause, and this is .dir. So let's just run this again. Click on the surface, and now you'll see that it's returned the two parts to me. There's the position in world space that I hit, so if I drop a point helper there, we're good to go. And then we're going to turn this into a transform matrix. This is where it might get a little bit confusing, but you know, sometimes it's cut and paste from other people. So let's actually go and make a point. I'm just going to say point 1 equals, that's actually just cut and paste because it's going to be far faster for us to do this. I'm going to go and cut and paste a bunch of, just called it PT. So I'm going to make a point helper. I'm going to turn on a couple of the properties. The box property crosses off. The axis tripod's true, so I can see which way it's up. Center marker's off. The size is going to be the control size divided by 2, so half the size of the control size. Wire color, I'm just going to make it red and set it. And I'm going to set a name right off the bat and use a nice little command called unique name. And unique name will take a name in the scene, and if I run that, it'll actually make sure that it sticks a 001 after it. If that object's already taken up, if that name's already taken up, it sticks a 002 after it, 003 after it. So I can give it a generic name here to get started, and this I call it PT for point, and I'd prefix this with the character's name eventually. And then this is going to be control root, and I might want to change those suffixes on the end as to something that makes sense, the top lip, upper right, whatever else it is, things of that nature. So there's a point helper. Now what we want to do is we can actually go and set its position. We're going to set its whole transform matrix, but let's go and set its position. I'm doing a bunch of work here, but let's just show you that it's actually functioning first. And let's go PT dot pause, or its position, equals hit dot pause. So I want to evaluate this script again. Click on the surface, and you'll see that it's made a point, and it seems to be a very, very, very small point. Why can't I select it? There we go. It's on the surface, but it's tiny for some reason. Let's say 10. I would have thought that was plenty big enough. There you go. And you have to sort of finish, you have to get out of your tool for it to finally build it. So you can see that it's made a point right on that surface. That means I could easily go around and make points on the surface. So you can see each one of them is actually right on the surface of that object there. That's going to make our lives a whole lot faster and easier to deal with right off the bat. Now what we want to do is we want to be able to actually build a transform matrix out of this. So let's discuss transform matrices quickly, and so you'll see where we're going again. This is going to help you, a whole lot in understanding if you look at the mathematics behind it. So let's go back to our gun with our finger sticking out sideways, our index finger sticking out sideways. This is a right-handed transform matrix. If you ever see me talk about left-handed transform matrices, that's a left-handed transform matrix. They're completely opposite one another. We don't want ever to end up in this case. We always want this. So there's our position value. What we have then is Z up, X goes side to side in our scene, and Y points towards us in the scene. So there's our Y value there. Each one of these is one of those vectors we've just been dealing with the ray. So in a transform matrix, there's no rotation value. There's no particular value of anything like this. So let's just go and make our point. And let's go and get, I'm just going to say $, which will just refer to just the currently selected object, dot transform. And I'm going to clear the listener and just run that. So this is a transform matrix that's actually been generated. Now, it's got 4 parts to it, as you can see. The last one is the actual world space value of wherever its position is. So that was easy. We set that using the hit.pos, pt.pos equals hit.pos, and we set that value wherever we hit that mesh in world space. These first 3 are actual unit vectors again. They're those little vectors that we were just discussing. I've got to find my, there I am. I got to make sure I'm looking at myself so I can see what I'm doing. So there's the position value here, and then each one of those is the point. So our object isn't rotated in world space. It's completely lined up. X is 1 unit out from its position along X. And if we look at the value, it's 1, 0, 0. So it's 1 unit out on X, 0 on Y, 0 on Z. That would be that point there, 1 unit away from wherever its position is. Y, 1 unit out on, or no units out on X, 1 unit out on Z, 0, or Y, sorry, 0 on Z. See, I told you I was tired today. Again, Z is up, 1 unit only. So these are good old Cartesian graph. If you go and create a little Cartesian graph like we used to back in grade 7 or 8 or 9 or whatever it was, and then plot these vectors, this will get you those points in space away from that center point, that center of the grid basically, which is that first knuckle there. So that's how a transfer matrix works. Believe it or not, these values here, I'm just going to turn off my webcam again. These 3 values here are actually represent the rotation and scale of the object in a transform matrix. There is, in a transform matrix lever, there is no angle change. It is all vectors being written like this. So because when we use our rays and get hits, and we get those little returned normal, we could actually go and use that normal to derive one of these and actually change the direction and the direction that it points in along that axis. So let's go and do that and build it up for us really quickly. So what I'm doing is I'm taking the hit, and this is going to be one that's a little grayer, but again, I think if you look it up on my website, I might even have some information about this. Basically, we're going to take the hit.dir, and that's the direction out from the surface, the normal points, and we're just going to make a little variable called z vector. I'm going to assume we want y up so that our little point helpers have y pointing up. So I'm going to make a new point helper that I'm going to make a new vector that just says 0, 0, 1. So it's actually pointing y up in the z. Okay. X vector is going to be built off of these two. So when you actually build a transform matrix, you can actually take 2 of them. We have our y pointing up now. We have our z pointing out of the surface. We can build this one now, our x, by basically taking these 2 and using something called the cross product. So you can see it says cross, and we actually can make this one from these 2 and actually tell it to build a vector that's perpendicular to these 2, actually sticks out from these 2. That's going to be our xv, so that's going to be our point here. And we use what's called normalize. And the problem is, if this vector ends up too long, you can actually end up stretching the object. So normalize makes sure that it's always just 1 unit in length. We're then going to rebuild our y. So we've gone and set maybe the normal of the z points out at an angle. Oh, hard to do this. It's like rubbing your tummy and patting your head at the same time. Maybe the normal points out like this, and we've set our z or our y pointing straight up, not perpendicular to it. It points like this. So then all of a sudden we create the x that points out sideways. What we want to do is we want to make sure this one is square to the other two and actually pointing in this direction now. So what we do is we use a cross product again of the other two. So we made z then y, we made x from z then y, and we're going to remake our y from z and x. So basically we can make one after the other and set them up that way. At that point we can make our own transform matrix. If you remember when we looked at a transform matrix, it's matrix 3. There's the x vector, y vector, z vector, and the position. We've got the x vector, y vector, z vector, and hit.pos. And we build a transform matrix, and we can apply that to the object now. So the difference now is if I click and run this, you'll see that our point helper is aligned to the surface, sticking cleanly out of the surface with the z. Our y is mostly pointing up. This would fail if we tried to put it right on the top somewhere. It wouldn't necessarily know which way was the best up. If it was a polygon that pointed straight, it's a vector pointed straight up, just like a camera, a target camera. As you move it over the top of itself, over the top of its target, it'll flip over. Same thing would happen here. So you can see that it's actually creating a point now nicely aligned to the surface and all in the right place. You guys kind of somewhat follow that? A bit of vector math for you. Again, next week I'm doing math class, so discussing some of that. That transfer matrix stuff is incredibly important when you're a TD, because if you understand it, you can manipulate anything. And I've mentioned many times about the dealing with stuff in production. I actually can make character rigs that will take the marker data from a mocap system. So just the marker data. It has no rotations. It's just a bunch of points floating around in space that were on the actor. And I can turn that into position and rotational data on controls using transforms like this, and making all that data up from a bunch of markers. So this is incredibly powerful to learn as a technical director and to get a really good grasp on. And I use it constantly for things like this all the time. Once you get it, you'll go, man, this helps a lot. Okay. So we're able to make this point on the surface now. I'm just going to get rid of those print statements. And let's go and make the rest of the bits and pieces. I'm going to make a second point helper. This is going to be our larger one. I'm going to set its transform just to the transform of the first one. I'm going to parent it, dot parent to the first one. I'm going to make a circle. Again, if you notice, I'm using the control size for things like radius and whatnot. I'm going to set its transform to the transform of the first one. I'm going to parent it to the previous one. So now we've basically got our control complete. I can go and click and just need to refresh the screen, and there's our controls. And if I hit page up and page down, it's all hooked together. So once we got that transform matrix worked out and set in place, you can see it's going to be a whole lot easier to create a control object now than it was before. I just drop them in place. One of the last things I did was just to move the point out from the surface, was do a little bit of work with an Xform modifier. And so I created an Xform modifier and added it to the control object onto our spline. And I moved the gizmo out and then just convert it back down to a spline. So now when we run it and I click, you'll notice it's actually moved the circle out, but not the actual pivot of the circle out. The actual pivot is still down at the point where we want it to rotate. Everybody good so far? Just so you know, I'll be giving you the script at the end of it all. A little confused of why the cross of YZ. we have to make x. We don't have a vector for x, David, so we don't know which way x points. And you get that by taking these two and finding a perpendicular point to it so that it sticks out sideways from it. The cross product will give you that. We don't necessarily know that it's going to give us a perfectly unit vectored one that's 1 unit in length. So we use a command called normalize that makes sure that it's only 1 unit in length. Does that answer your question, David? Okay, so this is now making us control objects. I'm just going to cut and paste a piece into here and that's a nice little query box, and it's going to go down in our first function, in our mouse tools function. And we're going to go down inside of mouse click do. Put that there. And what this is a query box. If you run a query box, it comes up with a yes/no sort of solution here, which returns a true or a false for a if test. And we're going to ask, do you want to actually make a mirror side one? And it's kind of groovy. It's a little hard to explain right now, but if you want to try and do that without having to mirror them over yourself, what we're doing is we made a hit here to start with that we fired. We made a ray. We got a hit. What I'm going to do is I'm going to take the hit point. I want to create another intersect ray target and actually fire another one at it. And what I'm going to do is I'm going to take the ray and I'm going to flip it over. I'm going to mirror, basically make a new ray value, and I'm going to multiply the position by a -1, 1, 1. So I'm actually flipping it to the other side of world space. And the direction, I'm going to multiply it by -1, 1, 1. So that I'm flipping the ray on the other side. So I'm actually taking our ray and flipping it to the other side of world space and firing it from the other direction at the surface, getting another hit and making another control object. So I'm just flipping this one over, its two component parts over to make our new ray. So if I now actually click, and it'll ask me if I want a new one, and I've now should have 2 of them exactly mirrored on either side of the model. So let's get to using our tool now to actually start building our rig and understanding how to build the rig. So it looks like 1 was the right size, and I don't know why it made it so small initially, because those are getting built large again. I'm just going to pull this right down small out of the way here. So let's start building our facial rig now that we've got a way to make points. And this is something I will take the time to write a tool that might take me what seems like a long time sometimes to figure it out the first time, because it'll make everything else go so much faster, and you never do anything once, it seems, when you're a TD. So let's start making some points around this face. I'm going to start with 1 dead center and drop 1 dead center here. So I'm just going to run my tool. I'm just going to go Control-E and evaluate it off screen here, and I'm going to try and click as dead center as I possibly can. And I'm going to say no. And if I shake that, it just needs a refresh. I should probably put a forced redraw in there or something. And I'm just going to run it again and just make sure I've got one on the bottom. And I'm just going to say no. And just right click to end. Why didn't I get a control? Let's try that again. Maybe it missed. No. There we go. So there's 2 control objects laid down in the right spot. Now what I can do is I can start building them around the mouth. What I'm going to do is I'm going to probably drop one about here. I want to drop one just below this tooth. I want to be able to pull this around the tooth. So I'm going to need a control here. Maybe one there, one in the corner of the mouth. So I'm just going to run that again. I'll put one about here. Yes. One about there. Yes. And I should probably put that refresh in. Yes. Yes, and I'm just going to make sure all those worked. So you'll see all those controls now are dropped in. Let's do underneath, and let's hit about the same locations. So I want to drop one there. Yes. and those are all in the right places. So you can see already how this has sped up our creation of points really quickly. Now here's one of those cases where I might want to move this around a little bit. Looks like that first point is being made absolutely tiny. I see what's happening. I'm multiplying. Here's I'm dividing by 2. I've got a value of 1. I'm dividing by 2, which unfortunately is not giving me a float of 0.5 unless I actually tell it's a float with a 2.0 in there. So it's actually creating, I'm dividing 1 by 2 as integer values, which you can't do. So it's probably giving me a value of 0. I should be doing it with the float. So we'll make it a float now, so it'll give me 0.5 because all of those are really, really, really small at this point. And it's going to be hard to see them. So let me just do a quick selection of my circles, where shapes. And let me just go size them all up real fast. Page up twice. We don't have something being linked. And that's a pain. What didn't we do? That's interesting. Oh, no wonder, because I'm in shapes, I think. There we go. Okay, so sorry, I'm tired and I'm trying to talk at the same time, explain things. So I've got all those picked. Let's just go and do selection dot size equals. We'll just make it size of 0.5, and then we can see them all. So once again, another good use for Max.Script is being able to type in single individual lines like that. So now we can see them all. So we've got these controls that allow us to be able to essentially move each one of these in itself. Now what we're going to do is we're going to start hooking them up to the jaw here. When this mouth opens, let me grab the animation on these controls and make sure it's gone. I'm going to leave it on the jaw only. So here's what we want to have happen. If you notice, these controls are being left behind, and they're not opening up obviously with the jaw. So those bottom controls are going to have to be linked up to the bottom, the jawbone in the bottom. So let's grab each one of these, and I am just going to grab that and that. I'm going to say hide. Grab the tongue and say hide, and should have 7 objects picked. I'm going to page up twice so that we've got all the main point helpers picked. I'm going to link it down to the jawbone, and of course they all open now. And they all pull open. Problem is the corner one isn't moving. So here's what's going to happen is that if we start linking these to one or the other, we're going to end up with a problem that either the top of like the corner of the mouth now is going to be yanked up here, and the bottom's going to be yanked down into this location when we skin to it, and it's not going to work very well. So let's actually start doing a little bit of a blending system that's going to blend things a bit more. What we want to do is we want to start creating some points that actually do only partial rotations. So right now we have a jawbone that's doing 100% rotation of the jaw, and we have a point back in here that's doing 0 rotation with the jaw. It's actually linked up to the head bone here that's in the head. So let's actually go and create helper's point. I'm going to make this one size of about 3, and I'm going to drop that in. Maybe even a bit bigger. Let's give it a 5 for now, make sure we can really see it, and it's nice bright green. I'm going to line it up to our jawbone in position and orientation. Oops, pivot. I'm going to link it up to the root of the jawbone. And then what I'm going to do is I'm going to orientationally constrain it between the two so that it does a half a rotation of the pair. So with that object pick, then I'm going to go to animation constraints, orientation constraint. I'm going to constrain it to the root, and then I'm going to go constraints, orientation constraint, and rotate it to the jaw. So now it's doing a half and half of those. So if we take our control object at the corner of the mouth and take the very root of it, what I'm going to do is I'm going to link it up to this point helper. And now it's doing a half and half. So when we skinned it, you can even see that even with our initial skinning, it's probably going to be about the right sort of place. What we might want to do is pull these others a little bit as well and pull those down a bit. So I'm going to make a copy of this one. And so I'm going to go Control V. I'm just going to say copy. And I'm going to make it a little bit larger. We'll call it a 6. And I'm going to go over to the weighting, and I'm going to weight it so it opens a little bit more in this case. So larger they get, the more they open. And so here's my weighting right now. So I'm going to take the top one down because that's the root of the jaw. I'm going to take it down to say 30, and the jawbone actually weighed up to a 70, I guess. And let's just close the jaw. And let's try this one here. And let's link it up to the that point. Now it doesn't open quite as far. It's blending up a little bit. May not be enough though when it comes right down to it. We might want that moving a bit further and a little bit faster. So we can easily go to the constraints and start playing around with these values. This is where playing around with these values can be a pain because you're constantly trying to balance off one to the other. Here's one of the first things I do, and again, I've got a tool for it. I'm going to say Alt-5 and just open the parameter editor. And with the parameter editor, I'm going to load up the object we've currently got picked in both sides. I'm going to go and roll down to my orientation constraints and pick weight 0, which is the first one. Roll down and pick the second one on the other side. Hook it, so the top weight's going to affect the second one, but I'm going to say 100 minus the orientation weight and say connect. So what's going to happen now is I can't actually adjust the second weight. I can only adjust the first weight, but it'll inversely affect the opposite side. This just, again, speeds up your workflow so that you don't actually have to deal with the weight between the two. So I'm going to do that with the previous one as well. (100 minus) to invert the value. And now we've got a case where I can go in and I can say, well, let's make this control drop down. You can see it's kind of making a bit of an S shape there. I can actually just grab it and I can just dial up and down the weight of that until it actually gets me to the right spot. So maybe 20 is pretty good. Maybe this one in the corner of the mouth should be up higher, kind of hold that value up higher so I can grab it then and just pull it up higher and play with its value. So this is where you can actually start fine-tuning your rig really fast and easy if you don't have to constantly type values back and forward. Also, when we make copies of these, we'll be able to get this already hooked up for us and doing the right things. So now that we have those, let's actually get a little bit of skinning happening and start getting the skinning around the mouth working so that we can start building and figuring out what else to add and how to get into that. I've been recording now for 1 hour 13 minutes. I need to save this recording down so it doesn't crash and lose the whole thing or anything. And we need to take a break and get some water or coffee or whatever. So let's take a quick 5 minutes and we'll come back and we'll start skinning in these controls, and you'll see how I work with these controls for the final rig as we start to build it. All right. I'm just going to mute myself out for that period of time. Okay, welcome back to part 2 of MC1303 bone-based facial rigging, and I'm just going to take a few questions. So guys, do you have any questions about sort of how we managed to get to this point with the script or anything that you want me to clarify? Anything that might help make you understand what we're about to do or direction we're about to go in, or anything like that? Does Max have log on action on viewport? Not sure what you mean. Will a script be provided? I don't know what you mean by log on action on viewport. I'm not sure what you mean by that, CK. Oh, you mean the ability to macro record, so it'll actually know what you've done. Yes, it does some. It doesn't do it anywhere near as well as MelScript does. Mel was sort of built in from day one, and everything was built around Mel. An ASCII file format in Maya is basically MelScript for all intents and purposes. Max will only capture probably about 10%, whereas MelScript will probably capture about 50% or 80% of what you're doing. The biggest problem I find with either, it doesn't matter whether I'm writing Mel or whether I'm writing MaxScript or anything. Anything you record is really making hacky bad code. So what we've all done here, all of this stuff, simply wouldn't be recorded in either language. This is proper code as opposed to the slop that's usually generated when you're recording a screen. It wouldn't know that you wanted to record by clicking on the screen a vector and how you're going to build it, anything like that. So it'll record some things. For instance, how to make a point helper, it would record that for you. So that sort of thing can help you for sure. But understanding code and being able to write code properly can help you in any. I always get these people who say to me, "Well, I'm a modeler. I don't need MaxScript," and then I show them how much faster I can make something than they can because I know a little bit of MaxScript or animation or anything else. Simple, fast little tools that can speed up my life, correct an error, fix something on a bunch of scenes, all those sorts of things. You know, MaxScript can help everybody out. What it boils down to is even if you just know a little bit. Normalize the script. That's not David, not normalizing a script. It's normalizing a vector. If we were to take a vector, I'm just going to go and just go Control D. I'm going to say V equals. I want to make a vector that has it's a unit vector, so it's in 1 unit in length. So 1, 0, 0. This is a unit vector. It's 1 unit in length. And if I actually run a command called length, v, gives me a value of 1. So it says it's 1 unit in length. If I make that vector 2 units in length, it comes up with 2. So it's stretched out and it's too long. What I can then say is normalize v, and what it returns back to me is it takes it and shrinks it back down to 1 unit in length again. And we always want to be working with those, especially in a transform matrix, because this, if it was in a transform matrix, just scaled the object by 2 along whatever axis we happen to put it in and direction we happen to put it in. So this is how you normalize something. So you could even make it, if it was pointing off in some crazy direction, and that's now pointing off in some crazy direction, and it's not normalized, it's got a big long length to it, we can normalize that down to those direction vectors that we were looking at. Yes, that first one that I did was in the x. So that one's pointing along world x, basically. And that's pointing down world x. So it's from wherever you are, from whatever position value you have, 0 on the z, 0 on the y, but it's pointing 2 units out along the x direction. So then we normalize it down to a unit vector so that we can utilize it better. Okay. The idea of a unit vector is that we can actually do all kinds of things with it in its length and everything. We could multiply it by 10, and we'd now be 10 units out from the object. Exactly 10 units out, for instance. Use it as a unit vector in transform matrix or in another array value or however we like. So that is how the base position, rotation, scale values of objects in 3D are dealt with is at the matrix level, and that is sort of the fundamental knowledge there of what a vector is and where and how it works. Any other questions there? Yes or no, so I know to go along and. Mark's good. You're not good, CK? Yes, it is. Well, I said it was intermediate, and I said I was going to get into some Max.Script, so that's what I like to do. I like to take you right to the edge. That's okay, CK. You could, again, using everything I'm about to show you, you can just forego and not use Max.Script and just make the point helpers yourself. A vector is in the space of the position, let's say. So it's relative to the position value of the again in the ray. There's a position portion and a vector portion of it. So if we were to give a ray value, ray position center of world space. Oops. There's a ray value that is at the center of world space. It's pointing down the x-axis, basically pointing down this x-axis down here, looking down x. If I wanted to make it point straight up, there it is there. If I move this object over 10 units along x, it's still pointing straight up from this point here. Does that make sense? So yes, this position value is in world space, and the vector is pointing from wherever the position is off in that vector direction. Not in up direction. I'm not quite sure you're asking now, so I'll just repeat it then. This is the position of our point that we were firing the ray from. So that's wherever that is, and in this case it would be 10 units out along the x, no y, no z. So that's just the position of the object. This vector, if we add it onto this, is where we're pointing the vector. So if you think of this as the starting point of our ray, and then if we add that onto that, that's the direction that there's the tip of the gun. So if you can think of this as the handle of the gun, and this is the end of the barrel, if we add this onto this, we would have 10, 0, 1. So that's 1 unit up from wherever it was. So we could really look at it as a point, points here. Let's just do this quickly. Helpers point. And this is going to be a really small grid. And let's just zero its value out in position. Let's make its size really small, because it's going to need to be really small. Let's say 0.5. And let's move it 1 unit. Let's do exactly what we've just done here. Let's take it and actually move it 10 units along x. So there's our 10 units along x. I don't know if you guys can see that okay there. So there's our position of where our gun is going to fire from. Let's just make a new little vector here. And so it's 10 units along, and it's going to be 1 unit up. So if we were to say, add this point to this one, there it is there. So it's pointing up. So our gun's firing from here, a line. It's making a line from here through this and continuing it on into the scene in that direction. First 0.3 value is world space. Yes, first 0.3 value is world space. So this object is 0 compared to this one. It hasn't been moved in x or y compared to that, It's been moved 1 unit up from this one. So if I were to grab these two and move them up, the position value changed on our ray, but the vector remained the same. It's 1 unit up from our position point. And again, we're firing from here through that point. Does that make sense then, guys? Yeah, okay. Knew I'd get there eventually. So when we're getting a ray back, it's the same thing. We're hitting a point on the surface, and we're using the normal of the, we're getting a normal back as our direction vector. So we're getting that position there, and then we're getting a little z vector that sticks out from this surface 1 unit away from wherever we pointed it along the vector. So again, we're getting this little ray pointing back out of the surface. You could theoretically actually write your own ray trace engine, probably be slow as hell in Max.Script, by bouncing rays around the scene like this. And I did it once for the fun of it. I actually built splines and bounced it like 100 times to a complicated scene for the fun of it. And it was kind of fun to do, where I actually built a spline and built its points based on every time you fired a ray, it would make a vertex on the spline and build it and bounce the ray and keep bouncing it like 100 times through the scene until it built a spline around the scene. And essentially you could see where a ray would have been fired if you had a light at that location. Why I did it was strictly for learning, and it was of no real use to anybody, but it was kind of fun to do. It was kind of like watching how a pinball would bounce, for the fun of it, right? So trying to sort that sort of thing out. Well, Mark, sometimes it's just a matter of learning things, and you just go about doing it however you can. People have made some pretty funny games in Max.Script and Mel.Script and stuff, and they've served no purpose other than for learning what you're trying to do. Burn in the image, yeah. Good way to put it. That's exactly it. And for me, it's like I was not a mathematician. For me, it was about understanding some of this stuff. Looks like I lost my teeth, oh, I hit them, didn't I? Okay, so we've now got them opening a little bit and pulling open. So one of the things I always used to do is I always used to skin the bones, and it seems to be what we're sort of trained to do, and I've done it for a long time. And you know what? I often find it just doesn't work as well as just skinning to the control objects. There's no huge advantage of having a bone there. Sometimes there is, and it can kind of work okay. But the latest rig and many of that I've done, I've just simply skinned up to the control objects. Why stick stretchy bones in between and have to skin to those? They actually cause a little bit of a problem sometimes. That if I stretch a bone between these two locations and then stretch one point away from another, but have these verts over here skinned to this bone, they'll actually want to shoot off in the opposite direction. They won't stretch this direction. They'll want to shoot in the opposite direction because they're past the end of the bone. So it can be a bit of a problem. It also adds a bunch of overhead because for every single bone you're going to have to add a look-at constraint and an orientation constraint to build a stretchy bone. And that's a lot of overhead to be pulling around your scene. So in this case right now, it's pretty much as simple as it can be. So we could actually work with this simple solution here and actually skin to it. Now I'm just going to pop into my skin modifier here, and I'm going to go and add some bones. So I'm going to go into sub-object, and I've got the initial bones that are already added in for the head as we dealt with before. And I'm just going to add one of these to start with here. Now again, what I've done is I've baked my weights. Always make sure you do that. So I've grabbed all of the vertices with vertex mode on. I've made sure they're baked so that envelopes aren't going to affect anything. And I've painting weights and set it all up. I'm just going to go in and I'm going to right click and I'm going to say add bones. That happens to be different, if you didn't know, than the add bones here. Add bones here actually opens up a list, and I prefer this one. This one adds just a point and click. So I'm going to add this circle, and you notice we get this crazy wacky thing going here. And the reason we've got that is it's actually created because it's a spline. You can actually use splines to skin to, and it's actually created an envelope around the spline. Since we got this tiny little circle going on, it's created this just god-awful mess. And I want to be able to skin to these splines and just use them as bones. for the most part these days, game engines should not care whether it's a bone or whether it's a circle or whether it's anything else. If it does, tack a little bone in here and just link it up to the circle if you wanted. But it shouldn't care. So this doesn't work very well. I'm just going to hit remove on that. And I'm just going to get out of the sub-object. What we really want to be doing is we want to be skinning up to a bunch of geometry, which for all intents could be bones. So what I'm going to do is I'm just going to grab all these. And now I'm going to go to my modifier selection, polyselect, and I'm going to stick a polyselect on there. And this can actually create a really nice little control object too. Splines are nice to select, but these might be easier when there's lots of them and they're small. One of the ways to set them up, object properties. I'm going to take renderable off. But before I do that, I'm just going to take the visibility down to like 0.3 or a 0.4, maybe a 0.4 for this. And then take the visibility off. And what you'll see is you've got these great little selectable control shapes now that are really easy to pick and kind of see through. So they're going to be nice little dots. And again, you can even make them smaller. They're easier to pick than splines are a lot of the time. And sort of easier to see. And make them a nice transparent and different colors for different sides or whatever else. And you can see them. So back in skin now, what's interesting, it's not going to see it anymore as a spline and give us that crazy circle thing going on that's blowing out all over the place. If I go and do the same thing now and say add bones, what it gives us is a nice little envelope right across. So I'm just going to go around and I'm just going to grab all of our control objects, not the point helpers. I want to add those all in. Did I just click on something by mistake? No, I think I got it all. Okay, so you'll notice that each one isn't affecting anything. Our jaw's still open as it was because it's skinned up as it was. So now what we want to be doing is we want to start actually creating the weighting for these controls. And before we do that, again, one of the best thing to do always when you're skinning is to go into your objects, turn on animate, and start animating them. Now another thing we haven't done here, which we really should do, is we want to freeze transform on everything here as we're working with it. In case we bump it, move it, do anything else with it, we can always get it back to its starting point. So I'm going to grab all of those, page up twice, control page down to select them all, Alt right click, freeze transform, yes. Now when I go and animate these or forget to turn on animate, I can always get them back to where they're supposed to be. I'm just going to turn on animate. I'm going to go and pull on some of these controls and just the control objects in this point and just move them around. And we could even do some craziness up and down. Let's actually take this one up, and this one down, and this one up. And now we have the ability to be able to go in and start skinning to these and make them work. So I'm using a Wacom tablet. Don't try and skin without it, is what it comes down to. It doesn't matter whether your little envelope is. I'm just going to use the paint weights function and the paint blend weights functions down here to work with the skinning. So in paint weights, I can just go in and start painting weights. Now, paintbrush size is Control Shift in Max, and Shift Alt is weight. And if you go to my website again and download skin tools, you'll notice that I've got a bunch of features that are in my menu here that you won't see in yours. My mirroring tools are there so that I can mirror them to the other side. Things like my paint mode, paint blend mode, some preset weights, update painter on mouse up. That's something you want to go and set. I find it works much better if you say update on mouse up. That way that when you're actually painting, you won't see the effect. It's when you lift the brush it will. Paint blending and whatnot will work better when you do that because stuff isn't moving for every single step of the way the brush is going. If you think about it, it's going to be calculating a lot. Also, if you have a complex mesh, it'll be very slow to update with that not turned on. And by default, it's off. So one of the comments I heard from somebody from Maya years ago was, Maya's paint blending is way faster and painting is way faster than Max's. And of course, the first thing I did popped it up and I said, well, it's not real time. When you paint, you have to lift your mouse by default. In Max, it's the other way around. It's real time. So it's sort of the opposite way around. So what we're going to do is we're going to make sure that's on. And when we're painting weight in, we're going to paint generally with a pretty low weight for the most part. And when we're blending, we're going to blend with a high weight. But what I have a tendency to do is I don't even necessarily start with paint blending. What I do is I grab a couple of verts in that area, and I know that everything around this corner of this mouth is going to have to be affected by this corner control. I'm just going to say grow, and I'm going to say 1. Wow, what a mess, right? So what's Paul thinking? I'm also going to go down to the remove 0 weights. Now that I've put all of the weights 100% into this bone, I want to get them 100% out of everything else. So what you'll notice, if you pick any one of these verts, even though I just heard a ping, can you guys still hear me? And recording still going. What was that ping? Okay. Oh, maybe it was telling me the data rate was slowing down or something. Okay, let me know if anything happens there. So you'll notice a vertex is actually being affected 100% by this bone, but it's actually still in what's called the bone list of the other 2 bones that were affecting it before. The problem is, as soon as I start blending weights on this vertex, it's going to take the weight out of this bone and blend it into the others that are in its list. Remove 0 weights, and it pulls any weight out that's under 0.01 of any bone out of any bone list. So now it basically removed the other ones from that area. I'm just going to go around to the next control here, and I'm just going to say grow, and just 1. Makes a complete mess, I know. And I'll just grab should have 6 there picked. Yep, 6 vertices picked, grow. And I'll just say 1. And same sort of thing. This one's going to be a little harder because there's not a lot of room here. I'm just going to grab grow. I'm going to say 1. And I'm just going to say remove 0 again. And then let's grab the center here. And I just heard it again. Is my voice breaking up again? Not sure what's doing it then. I'm just going to grab the center and just the absolute center here. And I'm going to give it a 1 as well. So now you start getting this complete mess going on. Let me just do a little bit more around the corner here so you can see where I'm going to go with this and how I tend to control this. Let's say grow, and I'm going to say 1, remove 0 again, make sure everything's out of the list. So what I'm doing is I'm just trying to set some weights and get them going. I want these ones to blend together, and I want to start blending them in and out of each other. So I'm going to use a little bit of, because this is going to be so tight to paint in, let me just go and grab these ones around here. And I probably want to blend these in maybe 0.5-ish. So now they're already starting to blend in 0.5. Obviously not a very good blend, but it got them spread out a little bit. This one here, probably the same sort of thing. Seems like a slow way to do it to start with. But again, it's one of those things I find that it actually can be. And is that one? Yeah, it looks good. So now that we've got these starting to work, what I can do is start blending and painting a little bit. I'm going to start, part of my voice sounding like a robot, I think, is that I'm slowly losing my voice here too, by the way. I'm going to start paint weighting now. So I'm going to go to my paint mode, and I'm going to go with a low weight, 0.05, so really low weight. That's even with a Wacom tablet with pressure effect strength turned on. And because I can go into a pose now, I can start pulling up that corner of the mouth nicely. Do something like that. Go over the other one and just grab that area a little bit again. Down the bottom here. And do some overlap. Now, as soon as you've painted, because I've painted the weights into this area now blending will actually work better because it knows what to blend into and how much to blend it together. So I'm going to go to paint blend mode, crank the strength up to 1, and you can see that now I can pretty much just go in and grab and start blending that area and get that area to work nicely. Go to my corner. We also know that when we go back to one of these corner verts, you'll notice that this vertex doesn't have the head bone or the jaw bone being blended into it now. That's because I made sure I removed 0 weights often and get rid of any of those bones out of the list. It's only blending in to whatever is currently affecting it. In this case, it's not even blending it into this one because it wasn't in the list. If I want to put it in the list and make sure it's there and it'll blend to it when I blend into it, you can even just go just a little bit of weight. Just need to touch it basically and to get it to turn blue. It's now put that vertex into the list of this bone. Go back to my control at the corner of the mouth. Blend with a high weight. I'm now blending into this one as well. So again, if I go back and pick that vertex, you'll see that it's now blending into all 3 of those. And I can go about blending those and blend back and forth. When you blend, don't just blend one because it'll pull it in a given direction. You want to go and check which the other ones are and see how nice and round the corner of that mouth is getting now with very little work. Bet you there's not a lot to push that one into. And they're going to go to this bone over here. And you can see that this one, oops, wrong bone. It's not affecting these verts here. Again, low weight, just get some verts into the list. Paint blend mode, and you'll notice now it blends in really nicely. And we're going to have to set this up with another effect. I bet you this one only has certain bones affecting it. It's even got the top of the head currently affecting it here. So these are some of these weights, ones that I haven't set yet. One of the things you might want to do, and it's something I don't do a lot, is paint mode, high weight, and just hold down Alt and get rid of some of the weights that shouldn't be in certain areas. I don't want the top of the head affecting the bottom, and then immediately make sure you hit remove 0 weights to get them out of the list so they're not there. But now what you're starting to see is a little bit of blending happening in the corner of this mouth here, and it's starting to look a little bit better. So again, low weight. What time do we have? We've got an hour left. Okay. Blend. Blend, and it looks like it's starting to pull it back and forth. Watch what happens to these verts here as I blend them. See, it's moving away. This one seems to be moving in. What I find is that, again, you want to blend back and forth. So it might be a matter of blending the other one to get it to go the right direction and get it to blend in. So that's just a matter of messing around back and forward with your weights and getting them to mix in. Something you want to also do is, part of the reason of having these controls animated is you want to see what moves. When a mouth moves and you're animating a face, let's get out a sub-object here, back into our control object. We want to make sure that when we move this, that we're actually getting a nice blending action going on. I think if you look right down here, you'll notice that this vertex is moving a lot. This one's not moving at all. And so you get this tearing happening down there. This isn't what an animator wants as they start to pull an extreme pose. So again, it's about going in, finding those locations. And it looks to me it's not even in the list, so I'm just going to go and add again a little bit in the list here. And then blend it out. Looks like these are getting a little messed up. They're starting to get jaggy back and forth, and they shouldn't be. They should stay in a nice row again. So I want to pick these and try and figure out what is causing that. It might be a little hand weighting, sort of one-on-one weighting that's going to be needed to make that work better. But now you're getting this nice curve happening in the corner of the mouth. You might want a tighter one when you do this, but I'm really pulling this control down and this one up, so I should be getting a pretty good rounded shape going in there. So if I go back to our control now and move it, you'll notice that it's moving a little more naturally in that area. So it's giving you that ability. Most games don't allow you to scale controls, but what's nice about not using the bones, using stretchy bones, is if you're not doing out to game engine and scale isn't an issue, what's nice is here is we can actually scale it. We can also rotate it. If this was a stretchy bone between these, rotating this in this fashion wouldn't do anything at all. The bone would just be pointing at it, and you'd have no way of actually controlling it. You'd have to have intermediary bones with extra points and all kinds of constraints happening to get that to work. And I used to do that. I thought to myself, what on earth am I doing? This is just way more work than's really necessary to make it work nice. So we can actually allow the animator to work with and pull this around. Now it looks like I've got some interior verts really heavily weighted that need to be sorted out. Don't constrain them pushing and pulling in any direction, rotation, or scale. And now the artist can actually be able to pull in a control up. That one's not skinned very well yet. Pull on a control, and they could even just scale it to be able to get different poses out of it, fat lip, whatever they decide they want. And our transform to 0 will get us back to 0. So that's how to go about laying in those controls. And then, of course, consider how much weight that we've got going around these point helpers that we had, if you remember, with the orientation constraints on them, to weight these up. What I'll end up with, right now I've only have 2 that's happening. So basically I've either got full rotation, no rotation to the head, or I've got 2 that are splitting the rotations a bit. I'll often end up with 3, 4, 5 of those in there with different rotation amounts to blend it off nicely all the way down around the jaw. This one will be affected a little bit being pulled down, a little bit more, a fair bit more, a fair bit more, and then maybe these 3 at the bottom are 100% with the bottom jaw sort of thing. So you can work it out so it's got some nice control on it. So what I would do is I'd go around this jaw and I would get all of these controls doing what they need to do and blending and pulling on the points as they're supposed to. I'm just not going to get time for that. I would then generally, again, depending on what sort of resolution, this might be perfect for a game scenario, what we've got right now with the amount of points or whatever, and worked out. We might want some around the eyebrows, same thing. We can lay them around the eyebrows and work those out. But what I would do is I'd probably paint the weights in on these, and then I'd add a few more where I think I need them. Paint the weights on those, get them weighted up again. Same thing if I did an outer row around the face that you see here, where you've got a second row around the outer face. I weight those in the same way as I have these controls to those orientation constrained jaw points, right? The ones that are rotating, not the whole direction around. Get those weighted up nicely first, then skin into them and get them controlling the face a bit more. What we can also do is get it set up so that we have some nice pulling happening on certain controls, so that right now to make the face sort of smile, I have to pull control after control to get it to work. Let me just grab some of these. I'm just going to say transform to 0. Looks like I got some real mess happening here in my weighting still. I'm not going to have time to weight it all up. I want to be able to pull this one control and have these other controls actually pull along, but only part way. So again, I'm going to go to the wire parameters dialog. So Alt-5. I hate going through this menu down here. It takes forever. So what I do is I load up. This is going to be my driver in a sense. So I'm going to load it up, and I'm going to load up its positions right here. And here's the track that's actually being animated, the zeroed out track. And I'm not going to wire these controls in. I don't want to wire the controls. I want to wire in its parent object. So the one below it, the one that's actually in below, and it's going to pull around that control object so that we don't end up with keys on this or being locked out or anything. I'll have this one wired in. So we froze transforms on it as well. So here's the position track for it. What we can do is actually, instead of going, and this is the problem with this, you can only, the param wires dialog, it'll take you only down to the very end tracks. Well, we know that position X, Y, and Z we want to have multiplied by 0.5. So I don't have to wire each track individually. I can simply go from my 0, okay, to the 0 of that point helper, connect it, and say multiply by 0.5, connect. And now what's going to happen is I'm going to be able to pull this and have it move along halfway. Again, on the bottom one, just load it in. And you can see it actually being pulling along halfway now. So now I've got something that allows me to be able to grab a point and it moves others. And again, sorry, my skinning is atrocious here, but I could still go and grab both of these and animate them in any way, shape. Oh, you know what? I think I did that control by mistake. Oops. Transform to 0. Let me see what I just did there. Yes, I did. I did it to the control by mistake because I'm talking too much. And let's just go disconnect. And I want to go up one, sorry. Now we've got them working, and I could animate on top and still have them offsetting. So again, this can just sort of, speed up the workflow for animators. If they're pulling on one, it would spread the load on others. Now what we don't have is the other way happening. It isn't working yet. We could also do this with constraints, but we could also get it to work so that these ones are halfway in between these, just with wire parameters if you wanted. What we can do is we can take the available tracks of our controls, so I'll do it with this one to start with, back to our point helper, make sure we load this in, and you can see that there's the available track. So when you actually do, let's open the dope sheet. So when you actually do a frozen transform, what it's doing is it's adding a list controller onto the object and stacking up controllers. So in this available track, we could actually wire that back and get it to do a 50-50 split. So let's take that available track and let's now go and grab this new control, load it in, and let's connect these two up. And it now affects it. So it pulls it and that pulls it. So basically we have a two-way connection happening just with parameter wires and without using a whole bunch of constraints. It's happening directly into the values of the control. So again, I'm just going to go down below here. That track is going to control that available track with a times 0.5, connect it up, and now we have a nice offset value going in to blend those at 50-50 in between. So you guys follow that with the wiring, the param wiring? Cool. Is that something new to everybody? Really handy way, really fast way to set things up, that's for sure. Using those. I mean, what a lot of people would do is they would do two-way connections and stuff. Trying to avoid the two-way connections, not a great solution. Using the point helpers and using list controllers is a great way of working and getting it to work. Now what we're going to do is we're going to start setting up. If you remember back to our control here, we've got some nice controls above for things like the corner of the mouth for handling some nice poses. And I'm doing a crazy one here where what I've actually got, I don't know if you can see this extra strip in here. This actually has morph targets on it. And the controls are actually on attachment constraints to this extra little piece of shape here. And I'm morphing this shape, which is pulling the controls around. It's ridiculous because of speed reasons when it comes down to it. They're not necessarily bad stuff in two-way connections. Aren't necessarily bad, but certainly what you'll find is keys only end up on one place, and they are certainly slower to be calculating and whatnot than what I'm doing, these direct connections, just one directional. You'll end up with less problems with them. It's certainly a cleaner way to work. So I would avoid them. I almost never, ever, ever use them, is what it boils down to. Sorry, just having a drink there. However, if you talk, it's like anything, you talk to 10 TDs, you'll probably get 10 different answers. Okay, so for my 20 years of experience working with Max, I basically try and avoid them because I find they don't give me much of an advantage and can cause other issues along the way that aren't necessarily going to make my life easier. So what we're going to do is we're going to set up a position, a system whereby we can grab a control, basically, in a sense, morph the shape into like a mouse shape like this, let's say. And then what we can do is we can still grab and animate and move those controls on top of it from that point on. So we're going to do it without morph targets. We're going to do it strictly with list controllers in quite a unique way. You're going to find it's kind of works kind of cool again and allows for some neat features to be achieved. I'm going to make your typical control object like we're shown there, and all those are, you guys haven't made them, it's just simply a rectangle. In this case, I'm going to make a nice big one. I'll make it 10 by 10, and I'm going to create a circle, and I'm just going to give it a radius of 1, I guess. I'm going to line it up to the rectangle, and I'm going to link it to the rectangle, and I'm going to freeze transform on it. Freeze transforms always have to come after parenting. So there's a control object for the corner of the mouth, let's say. Put a nice little text object above and start building your fancy little control object UIs. So what we've got now is a case where if we look at the dope sheet again, and we look at the position values in our zeroed out track, we got 0, 0, 0. Move it up, or move it in Y. Move it right up to the top edge. We get 5. Move it down to the bottom edge, we get -5, -5, an X, positive Y, and so I'm just going to say transform to 0 and pop that back in. So this control can help us to manipulate and move it around. Now, one of the things, because it's 5 each time, that can be a little bit of a pain. What you might want to do is build them in 1 and scale them. I hate scaling stuff, but this is one of those cases where sometimes it can actually make your life easier. So if we actually made this units of 1 and 1 and made our radius smaller, now it'll actually be a unit of 1 when we go out. You can see I'm, well, at 0.5 actually. I guess I should go, we'll go to 2 and 2, sorry. So that's 1 unit along in X. And if I look at parent space, I'm 1 unit out in X that way, -1 this way, and I can start hooking up things to it. Now this is going to be a really, really small control, so what you can do is you can build the UI this way, and at the end of it all, grab the one master control around the outside and scale it up to the size that you need. It's still only going to be 1 unit in distance because scale is now come into case. This is one of the few times I would ever scale anything in a character rig, okay? One of the very, very few times. One of those, rules I don't like to break. So I'm just going to scale this one up anyways, just so we can see it better. And I could even go and just make this easier to pick. I could go and say modifier select, poly select again. So I got this little blue dot in the middle. Make it kind of cool. You could even do it on these too and make it transparent and not selectable and all kinds of funky stuff to make it look kind of fun. So now what we're going to do is we're going to set this up so as we move this control around, we're going to be able to control different poses on the face. Now, one of the things that I find is creating a smile slider will get the animators one smile and one smile only, and only one way to get to that smile. What we want to create them actually is a system whereby we have a mouth corner that goes up and down, mouth corner that goes in and out, and then allow the animator to pick and choose how they get to that value inside of that slider. Now, how in earth are we going to do that with these control points? With a morph target, it's not so bad. It's just a 0 to 1 value. But here's where list controllers are really, really powerful again. I'm going to grab just my ones that I want to work with here. I'd probably want to go out to here, but my skinning isn't complete. I'm going to page up one. Okay, so that I've got my those underlying controls picked. And again, they have a list controller on them that's going to allow us to be able to push and pull these and move them around. Now what I'm going to do with these, and I'd do it with all of them. I'd do this once I've got all of my facial controls in there. I'm going to add another controller to each one. So I'm going to go into the available track of each one, and I'm going to add a control that's going to be corner out. And I'm actually going to rename it so that I can see it as we go. So let's just do it to 1 to start with, and I'll show you how to do it quickly. So I'm going to go into the available track, right click, assign controller. In this case, I'm just going to use a Bezier position instead of a position XYZ. I don't need to worry about all the separate tracks. I'm just going to say Bezier position. I'm going to go into the rotation because I might want to rotate it as well. Available track. And in this case, I'm going to use a TCB rotation, quaternions. Again, I'm not worried about function curves for animators here or anything like that. I just need the thing to be able to rotate real easy, and it just simplifies having to see piles of tracks. So I'm going to go and add that in and say TCB rotation. And what I've got the ability to do now is set each one of those to be active. So if I go into the first list controller for the position, right click and pick properties. Currently right now, if I move this object, you'll see that these controllers here are the ones that get the position value change. You'll see that the X and Y got the value change, and our new Bezier position controller did not. It's because it's not active. Just double click or click on it and say set active. Now when I move it along this track, you'll see that that new Bezier controller is the one that gets the active change. So it's going to allow me to change that one. Again, I'll have to do that in my rotation as well. Hit properties, make my TCB active. So this is where it's going to get neat. What we're going to do is we're not going to worry about trying to wire up and figure out how to wire the XY positions and rotation values to this to be able to get it to move straight out. That would be craziness to try and do. It would be a real pain to try and achieve. With those new controllers active, I'm actually just going to make sure they're named appropriately too. I should have done that. I'm going to call this corner out. And I'm going to go into the rotation and say corner out. That way I know which ones I'm looking at when I start param wiring. So I'm going to grab this control now, and I want to say, well, let's make it kind of pull out and up or something. So I'm going to pull it out and up, and that's going to be my corner out. Notice it's not pulling these ones. It's because we didn't wire up that layer. It only works when you grab the control. That's okay. I'll be pulling these ones out as well too. So I'm going to pull that out. So instead of trying to wire up these position value changes, I'm going to think of this like a morph target. And what I mean by that is if you open up a list controller, it has weights. And if we look at the weights, again, you can either get to that dialog here or here. It has a weight. And so this corner out has a weight. If I dial down that weight, you'll see it go back to its initial point. It actually completely dials it back down to 0. So if you think of this as a morph target from 0 to 100, and in this case it can actually get pushed further. What if I wire this weight up to my control and just drive this weight 0 and up and down, and this weight up and down? It's going to be a lot easier to hook up to my control. So let's go back to our param wire dialog, load up the object we're going to drive, open up the weights. There's my corner out weight for position. Here's my corner out weight for rotation. Let's get the control object. It'll be along -x is what it's going to be dealing with. Let's just load it up over here and say position of this along x. And what I'm going to do is I'm going to have to flip this value over and whatnot. But let's just do this. So I only want this to work if I pull this out. Okay, so this is a corner out. I don't want it to work on the other direction. So I want to say if X position is less than 0, then, and I'm going to stick a, I'll just do parentheses to make it really clear here, else. And the else is basically going to be 0, so I don't want anything to happen inside of my else here. I just want it to be 0, so that if I move it this direction in a positive, nothing's going to happen at all. It's not going to move it. And the other one is going to actually try and set the value. So let's actually just take that X position and drop it in here and see what happens. And this is currently for the rotation, which I don't think I did. I'm just going to grab all of that, say connect, and I'm going to connect it up to the position as well, connect, and you see it suddenly jump back to where it is. Drive that out. It's actually driving it in the other direction. Doesn't do anything when I go forward in the X. It's going the backwards, opposite way, because it's actually driving the weight down to a negative value right now, because quite frankly, X position is completely backwards for us, and we want to invert that. So I'm just going to stick a negative inside of it, and now it's going the right direction, and I need to make sure that is the same for the rotation. So now it's pulling it out. So basically it's a morph target system, not using any morph targets. Do you guys follow how I've hooked that up now? I'm using the weights of the list controllers to determine how it's going to be set up. Are you guys good with that? Yes, I determine the max pose by moving it. Now here's the trick, is that I can move my slider all the way to its maximum position, let's say, 100%. I can actually go back in. I can grab that control now, and I can pull it further, let's say. Well, that control object now functions for that distance. I could also say, you know what, let's get a little bit of rotation in there, because we also wired in the rotation. So let's rotate that a little bit. Skinning stinks, by the way. Maybe we want to pull it out a little bit. And again, now our slider is actually working for that value and pulling that in and out. Now we have to make sure that this controller is the one that's active as we're doing this. From where controller appears the weights, I only see the assigned Bezier position and TCB rotation. You mean here? Is this what you're looking at? Sorry, David? Yeah, well, this is the weight of the first controller, second controller, and third controller. And so basically we're creating morph targets with list controllers. Now this is a pain to manage. You want to do this with every single one of these controls. It's gonna hurt you pretty fast, and it's going to be quite a pain to do. So let's actually just grab. I'll just do it to these two, and I'll do it the quick way. We're going to go and grab rigging pen rigging utils. This tool has been around since about Max 4, I think, as far as I know. Give me just a sec for a drink, sorry. And people still tell me they use it all the time. It looks like it has some errors in Max 6. For most part, it's working. A couple of the tools aren't working properly, though, but maybe one day I'll get around to fixing it out. It's downloadable for my site again. I'll just go to my site here. And scripts, and darned if I know where it is. Rigging utils. And here it is, downloadable from here. Okay. And so what we're going to do in pen rigging utils, we're going to go to the controllers tab. And with these two objects picked, what I'm going to do is I want to say make a new controller. I want to make a Bezier position, and I want to add an Euler XY or TCB rotation, and I want to call this one corner out, like I did before on this one here. So I want it on these ones as well. And I want to say make it active when I hit go. So I'm going to say add replace. What I just did was added new controls to this, to these objects with corner out, and they have a weight, and those controllers are also set to being active. Okay, you'll notice these ones have position wires on. Order of these doesn't necessarily matter, but I like the name in there so I can see what's connected to what. Again, this is going to make it a whole lot faster for me. We're still looking at that same bit of math, and I'm going to hook it up to the weights of the position, corner out, and we want to basically pull those out the same amount. So I'm going to just copy and paste that chunk of code that worked, and for the rotation, corner out, and for the other object, weights, corner out, and for rotation weights, corner out. And personally what I do is I write a script to do this for me. So now let's make sure our control, because right now it's interesting, if I actually zero my transform on my control and try to move one of these, you'll notice it doesn't move. I'm trying to drag and move it. Well, I actually did just move it to wherever I let it go. It's just that its weight's to 0, so the value changed, but it doesn't have any weight. So I'm going to make sure that my control is set in parent space to its control object, to that -1. So it's yanked all the way back over its full of value. And now I can go in and grab this control, pull it maybe halfway back. Let's just rotate it a little bit, make it look nice. Grab this one, pull it halfway back. Again, my weighting stinks, so just ignore all this mess back here. And now guess what? It's all hooked up and working as well. And it looks like, oh, I did it again. Up to that parent one, sorry, up to that parent point helper. And I'll just rotate that one into place. And there I go. I can actually go and adjust at any point in time. Now, once you start getting a lot of these set up, it can be a pain if you want to go back and adjust one, but my tool allows for that. Anytime you pick an object or objects that share controllers by name, they'll show up in this list at the top here, and you can just say, okay, controller out, and it puts the name in down here. For you know it, you can just type it in down here, and then you can say set controller, and it'll set that one active by its name. So you can hit set controller by name, and now you know you're manipulating that pose basically. So you can grab all the control objects, page up one, get into their parent point helper, make sure that the one that you want to adjust and work with is set to active, make all the changes you want, and away you go. Your slider currently works. Now again, you want to make sure your slider that you've set up or whatever it is set to 100% value on it, or else you won't see a change happen on that track because its list is dialed down to 0. So that's a really quick way of setting up some really slick sort of morph targetable points, as opposed to having to deal with morph targets and all the attachment constraints and all the other crud that I did for years on rigs. And again, it's one of those things, something suddenly dawns on me and I go, what on earth was I doing, right? There's just no sense to this. Every time I start making something more complex, you have to reel yourself back in and say, is there a good reason to make it more complex? This is really fast in a rig, and it reacts really, really quickly. So now we've got the ability to be able to have the jaw open with our jaw control. Open it up. Animator can grab a control if they want. They can animate it. They can also grab their sort of preset slider and play with it as well. So to reset the mouth, they actually have to do transform to 0 on the control, and then a transform to 0 on these, and of course, transform to 0 on the jawbone itself to be able to get back to the place. And again, that's something that can be scripted into a tool set or whatever to make it all start to work. So this sort of system works quickly and cleanly to make it accessible to everybody. I'm going to take a break again quickly and save down my recording that's been going for an hour again, and I'm just going to set up the eye and show you how I do an eye, and then we can do a question and answer period. All right, so I'm just going to mute myself out here and cancel my screen for a bit. Okay, welcome back to part 3 of bone-based facial rigging MC 1303, And we're going to take a look at the eyes now and do some eye setup here so that we can get it running. So close down a couple of these dialog boxes. Eye rigs are fairly straightforward, really. We're going to use bones because it's sort of the best visual, feel of it, so that you can actually sort of see what's going on. If the model's been generated properly, and that's the hope that it has been, and this one certainly has been, you can see that the eyelid fits the eye nicely, no gaps or holes. I've had cases where clients have sent me, models where the eyeball doesn't actually fit in the eye socket, and then I set up, bone-based rigging or morphing or whatever else, and the first thing they say is, "Hey, there's gaps." It's like, well, there's gaps from the start, so I don't know how to fix it other than fix the model to begin with. So, make sure this all fits nicely. You also want to make sure in a model, if you're going to get nice shape, that you've actually got enough points around the eyelids. Again, if it's a real low res game, maybe the eye's just going to close. But what I like to be able to get out of a cartoony character is something that actually gives us an S shape out of eyelids. So that, if we furrow the brow down, and get a furrowed brow, we can even furrow the eyelid. Something we obviously can't do, but it's a great way of getting nice shapes and forms out of the eye to get it to really look good. So what we're going to do is start off by getting a bone down and pivots down in the right spot here. So I'm just going to say create system bones, and this is the system tools bones or through this menu. I stick my, again, as I always mention, I stick my top menu here into my quad menus so I can get into things really fast and easy over and over again. I'm just going to check and see what size I'm being made at. Way too big, 0.2 maybe. That looks pretty good. So I'm just going to pull a bone up real quick here, just from the center-ish right now. It's about the edge of the top eyelid. Go back down, grab the root of it, and I'm going to use my align tool, so Alt-A, and align it up. And in this case, I'm going to have to go center to center because I don't think the pivots after me doing some work are going to work. I'm going to say XYZ off. I'm going to say OK. And I should have, and I don't have, did I miss what I was picking? I had to set this up fast, and when I pulled the rig apart, it kind of blew up really quickly. Why aren't I seeing? Yeah, it should work. It should give me a center. Center to center. Well, that's, to pivot, of course, sorry. So align the pivot to the center. Sorry, I am getting tired. I'm starting to fall apart, but it's still not getting me exactly what I want for some reason. Pivot to center. No. I'm surprised that's not getting. So I'm going to guess at this. Because right now I have, I'm just going to have to guess, which isn't good. I normally don't guess. I'm going to stick it in the middle of the eyeball and hope that's about the right spot. But usually you should be able to line it. Something I did there when I was pulling the old model apart and cutting it up. I did it first thing this morning. I've obviously done something wrong. Probably didn't reset the eyeballs is the big one. So there it is. It's going to be in the right spot. Now, when we pull this down, we rotate this down. If you see the curve of the eye here, and we rotate this down to pull that front edge down, we can't just use one bone to really do this well. Somewhere in the middle of the eye, and there's not a lot of segments around this, so let's say this row here that you can see of points is going to end up somewhere halfway. Bottom one's going to end up at the very bottom. Problem is skinning is linear. This line here will end up getting pulled down to the middle of the eye and not out to the edge of the eye. So really what we're going to need is we're going to need two bones on the top and probably just one on the bottom because we don't need to pull it up as far. But we're just going to go with the two on the top for now and have a look at it and work with it. The other thing we're going to do is we're also going to set it up so that we've got the ability to try and get an S out of it. So I'm just going to actually rotate this one over to the side here a bit. I'm going to go page down and I'm going to shift copy that over to the other side. Somewhere over there. And that should be pretty good. We're in the center. Looks like these have gone all wacky when I did that. And one of the fixes for that is you just delete them and open up your bone tools and just go about re-adding them. So I'm going to say create end and create end. So there's the, excuse me as I keep coughing, my throat's starting to go. There's those two bones that are going to rotate down and be able to create a sort of an S shape going on. I'm also going to make the next row, so we're going to need another bone. I'm going to rotate one up here. Say OK, create end. And I'm going to rotate this one up. And that's in about the right spot. I'm going to say create end. And I'm just going to have time probably just for the top lid here, so I won't be able to do the bottom one. Now what we want to do is we want to create some pivot points for these and to link them into the system. Now, I always prefer making sure that all my bones are terminated with a point helper before I link them into another bone. And one of the tools you can do that's again on my site, which is called mgroup. And for some reason, it's not installing in 2013 all the time. But mgroup, something I've done wrong in my installation, and because I don't use it out of there anymore, but you can go get it off my website, and it looks basically the same as this one here, which is part of my floating tool set. So there's the same UI. And what it allows you to be able to do is, and if you've ever used Maya, there's a group function in Maya. Oh, really, David? You got the same problem with mgroup? I don't know what's going on then. I'll have to take a look at where the macros are pointing to. Maybe that's all it is. The macros might be trying to load it and aren't or something, or I don't understand why mgroup wouldn't be loading as a macro properly when all my other macros do, and it's in the same place. I'll have to go back and look at it then, but you should just be able to run as well, just the script that runs, the MS script. You should be able to get in and run it if you need be. So what I'm going to do is I'm going to set this down to small point helper size, 0.2. It's going to say I'm going to stick a point helper on the local orientation of every object selected. So I'm going to group each object, and it's going to show the point helpers at this size, and I'm going to say group. And now I have 4 point helpers that are basically each of the bones is linked to each one of those point helpers. It'll also keep it right in the middle of the hierarchy. If the bones are already linked up to the bone, and then you pick the bones, it'll put the point helpers in the middle of the hierarchy. I'm going to grab those and link them down to the head bones. Now they move that head bone and rotate with it. We're going to need to set up a control again for these, and we'll use some nice sliders up above. But what I want to do is I want to freeze transforms on all these. Freeze transform, not try and reset transform. And I want to make a new control object here, and it's going to be for my eyelids going up and down. Now, I'm not going to need the width on any of these. They're just going to be, up and down for each side. So that's going to be one side, and that'll be the other. And we'll be able to push them up and down. Now, we may also want to push the slider to the top, but you'll see where I'm going with these as we start to hook them up. So first off, we want to get something working. We'll look at the rotation on them, which is going to be around the Z-axis to be able to move those up and down. So again, I'm going to go into my param wires with Alt-5. This is going to be the driven one, so down to the Z. And this is going to be on the local Y up and down. And we're going to say position Y, and I'm going to hook it into it, say connect, and it'll be a little hard to see, but I don't know if you can see the bone going up and down now as I push that up and down. I might need to actually slow it down or speed it up depending on something, so I might say times 0.5, and I can get it to go up and down. Maybe not enough anymore. You know what? I think I'm just going to leave it as it was and just say update. Good enough. So that one's going up and down with it. The one above it is going to be the same thing, but with a half. times 0.5, just to make my life easy, and so I don't have to think about anything related to math at this point. And so that should be one control hooked up to the two. I don't know if you can see them that far away. What I might want to do is split my screen or something, make the control even smaller. You know what I'm going to do? Let's do this. Let's put them down there for now. How's that? It's probably easier to see, right? So this control is now, it's pushing them up and pulling them down. So that appears to be working as we want. Let's hook up the other side. That works, and then we'll hook this one up too, so we've got both of them working. So that should have all of those working now and going up and down. So that just allows us to be able to spread out the eye and get it spread out nicely. We probably don't want to have to push it up, so we could again work out our control so it doesn't go up. You can also put limit controllers on these to stop them from going where you don't want. Again, I tend to avoid it because animators always get ticked off at me when I limit anything, even if it doesn't make any good sense at all to do it. They seem to get annoyed at me, so I just don't. So now that we've got that, what we want to do is we want to start setting up our weighting. So let's pull the weights down, or the timeline down at 5. I'm going to pull this down all the way, and that should be in parent space now. It should be -1 in y. So let's just make sure it's -1. And this one should be -1 in y. So they should both be closed, basically. I'm going to go along to frame 20. I'm going to reset this one. And I'm going to go along and actually close it again. And I'm going to put that one there and then reset this one. So now what we get is sort of the extremes of everything, so we can see what's going on. Always the best way to go about your skinning is to sort of set up those extremes. I'm going to pull it down about halfway. Actually, sorry, leave it at frame 0, back at the default position, and then I'm going to add these bones in. So I'm just going to change my filter to bones, make my life easier, and don't pick things by mistake. Say add bones and add all 4 bones, and just get out of that. And now I'm going to go down, take it halfway down, for instance, right now, and go back to doing the good old trick of working on points individually. I'm just going to isolate my selection too, so I can see what I'm grabbing all the way inside the eye here. I'm going to grab that probably all the way to there and there. I'm just going to say 1. And immediately right now as well, as soon as I do that, I like to say remove 0 weights. Over on the other side, I think it's probably somewhere, no, it's going to be one of these, or if not, both of them. And I'm just going to grab these again. And I would say 1. Get rid of the 0 weights again. Likelihood these will be 1 as well. 0 weights, because these are the halfway ones, and that's my halfway line. So I'm just going to start with that for now. And then I'm going to start trying to actually get this eyelid to close nicely. Looks like it's going too far with -1, so my math might need a change in my slider, but again, the animator doesn't have to pull it that far necessarily. So what I want to do now is I want to start actually working with these other parts. So I'm just going to grab all those, try and make sure I haven't selected anything out of the back of the head, and start weighting them up. Now you'll notice as well those points are all currently weighted to the head 100%, and we probably don't want that at all. I want these to all completely be affected by these eyelids. So to get it out of that, the first thing you should do is just set it to 100% to one of the bones that you know that are going to have effect on it. Remove 0 weights so the head bone is out, and then we can go about giving it other weights to the other bones. So we could actually say, let's actually pull some weight into that if we wanted. and you pull it back and forth. So same thing goes the other way. I could grab these ones here, make it 0 weights, go to the other side. I could give it some weight on the other side if I wanted. It looks like these are going to have weight pulled out of them, most likely. So what I'm getting now is the ability to be able to get a little bit of sort of blending and flexing going on. So again, I'm going to grab them, and I'm just going to say 1, remove. And then I'm going to start pulling some of the weights back into, oh, resolved connection. Sorry, you guys having a problem there? Did you guys lose me? Oh, you lost it? Oh, anybody else? David, was it just you? Okay, so maybe it was on your end then, David. All right, let me know. I seem to have my recording still going, and you guys can still see my screen and everything, right? So we're good to go. So as you add these, again, it's the same thing that I find is you want to make sure that you go and get everything into a weight, and then we'll pull them back out. So I'm going to grab everything I know is got to be affected at least by this this control here, and at least just crank it in 100% on this one, and I'm doing this pretty quick. And then we can start pulling them back into other weights. Even if it's back into the head bone now, I'll have a better idea of where I'm going with it. That one down, and I'm just going to put some weight back into this one. Same way here, I'm going to say 1 and 1 on that one. Let's give a 1 on this one as well. Remove 0 weights. So we can grab these and just say 1 and remove 0 weights. Now let's start pulling some of these corners back up and trying to get them to work. If you notice, I'm able to do this entirely with the weight tool and not even trying to paint weights necessarily. So that's obviously being pulled down too far. Well, what happens if I pull some weight back into this? And this plus sign will add just an amount of weight back in. It may not even be enough in this case because that corner's got to stay up. It may have to go back in to the top of the head. That's fine. I can put it into the halfway bone, and then I can pull it back up a little bit. So the trick is just to find the balance of each one. I'm going to start with the eyelids, and I'm going to pull that back up. What I'm looking at doing is trying to get a nice curve going on this eyelid. And you can see that these aren't really working out quite the way we want right now. These are too much. So we're going to have to pull the bone further. This is a 50-50, and we're going to want that nice blend going in there anyways. So what we're probably going to end up doing is putting more weights. None of them are going to be 100% to these bottom bones. And let's just go back to this. And let's take that up. Might have to go back into the head bone a little bit to stop it from going too far again. I think I grabbed verts in the back of the head there by mistake in my haste trying to get this. I've got something picked way in here in the eyelid that I'm going to have to fix. I can pull that up, and I'll pull this one back up into the head a little bit. And again, I'm just trying to get this nice arc going. So you can see that I'm starting to get a nice arced close on this side. And again, it looks like these ones are probably just going to have to move very little with the eyelids. I'm going to have to pull them back in. And then we need to start looking at the actual curve between them. We've got to fix the down shape on all of them first, and then just try working on a blend between the others. So I'm going to grab that, and I'm going to say pull that up, and I'm going to grab that, pull it up. It's not too bad actually. I'm going to bet that I'm going to need some up on the back to the head bone again. Now I can start thinking about that curve and getting that curve. I've got a bunch of verts that I keep grabbing in the back here that are getting pulled through. You can see that eyelid's starting to close now. Looks like some of these are still going to have to be addressed. See it pushing through. There's just not enough geometry in this model when they modeled it. So the other thing I might have to do is pull down some of these. And I'm going to do that. I could do that just with a paint tool, for instance. Start pulling these down, and it'll help solve that problem. And it should be working over the eye pretty good now. Now let's get that S shape going. So you see we don't quite have a nice S shape happening here. We need to figure out how to get that to work. I think that we're going to need more weight on, looks like it's pulling it up when I'm putting it into that one. Oops, no wonder I'm on smooth paint weights. There we go. Let's pull that down. Hopefully that gets us a nice shape still. And maybe we want a little bit on this one. Getting a nice curve going. When that's got a turbo smooth and we fix the corner here, it'll be good. And again, let's take a look at doing it the other way and try and make sure that we've got a nice shape happening the other direction. And it's not too bad. Maybe a little bit of curve there. Now we have the ability to be able to get nice crazy shapes on our eyelids just with a couple of bones rotating. And again, I need to fix all those ones that are being pulled inside by mistake from my haste just trying to get this done. So I think you can see that we're getting some nice curves going, and you'll want to get the same sort of thing on the bottom of the eyelid. The trick with the bottom of the eyelid is weighting it up, same thing, two bones, same kind of spread, and see if you can get them to fit and blend in so that you can actually get the eye closed on this crazy curve going. And the animator then can get this, you know, like sort of almost a mad closed eye in a sense. You know, so it closes up really nicely and blends back and forth really well. So looks like I've got one, not quite. Always the perfectionist. Even on my demos, I want to try and get it right. So you can see you've got this nice curving happening, and that nice curving is going to really allow for some great looking shapes. It never needs to be pushed that far necessarily, but you know, if you look at an eyelid just curved a little bit like this, it adds a real anger sort of feel to it. Or just a little bit the other way, it adds a real sadness to it. And now I'm just going to get out of my, we should be able to get some nice shapes going with those eyelids. Just being able to close them down or maybe open it up a little bit. So I'm actually forcing it open a little bit further. Nice angry eye. Or just force it up a little bit and very wide-eyed. Very sad, sort of lazy eye. Just from a couple of bones and being able to skin it properly. Obviously all this mess in here needs to be worked out that I've just been going too fast and not sort of dealing with it. And again, you know, it depends on, you know, in this case, this would not be necessarily a game setup. A lot of simple game setups might be one bone. That's all you've got. You've got to figure out a way to make it close over the eye. You know, even push the front of the eye in a little bit so it's not perfectly round. We're never getting that close to the face, so who cares sort of attitude. We just need to make it look like the character can blink. To the point where you want to be able to get nice form and shape and expression, and there's going to be a lot of acting involved, and that'll allow that sort of thing. The other thing to do then too is we could also go and do this same sort of setup as all these points around the mouth. We could actually put a bunch of them around the eyelids, around the edge of the eyelids, and instead of just skinning to the bones, we could have those main bones rotating, and they could just be point helpers for all that fact, rotating to get this overall close, just like we've got an overall open with the jawbone down here. We could set it up so that we've actually got a series of a few points around the eyelid that the animator can grab, but the main driver is actually driving some nice rotations on bones and opening and closing them, but then they can grab that edge and shape it completely how they want. That's getting very specific. You know, I'm quite sure if you looked at you know, a Pixar rig, they'd have just hundreds of control points all over the surface so that they can just push and pull it any way they want. They obviously have a huge amount of time for development, and they have a huge need for huge amounts of control. So you need to pick and choose what's best for your production. TV productions may not need it. Get away with them like this, where they just give the shape, being able to give this nice, being a blended sort of shape back and forth, and it can really help for the. I shouldn't do that so fast. I forget you guys aren't getting real time. I'm still not getting. You see, it's still pushing through. So some of my weighting's got to change to stop it or make sure that it rotates properly through that rotation. So these points here aren't being weighted heavily enough to the bottom ones. I'm going to have to fix that so it doesn't go halfway. Either that or push them out. The other trick is to wire in the position of the bone going out a little bit as it goes through the halfway point. And that can be done too, just to push it out along that local axis so that it actually pushes it out and make sure that it doesn't get pushed in like this. Again, most of it can be addressed through weighting and solving the weighting. With morph targets, it's not so bad to make that intermediary one not do that. Correct. Yeah, you don't. And again, you go into games. You don't. Stretchy bones won't usually go out to games. So you're just moving the bone. It doesn't matter to a game engine. It's looking at the bone as a rotation positional. The transform matrix of it. But it tries to negate any scales usually. So you can avoid it just by moving them. Quite frankly, if you look at Maya, they don't have stretchy bones. They don't have the ability to be able to stretch a bone in the same way that Max does. And so they tend not to. They just move them apart. Really what we've got is a typical sort of myofascial rig in a sense here. It's not that you can't stretch a bone in Maya, but you'd actually have to scale it purposefully and go in and scale it. It doesn't have that built-in stretch factor matrix that it does in Max. And again, you could do it that way in Max as well. So you've kind of got an option there. But I think we're pretty much at the end of sort of solving this. Again, we obviously need a lot of weighting, a lot more controls. Controls maybe around the nostrils, eyebrows, cheeks. You can add them in other places. I'd put, frankly, bones in each of these so that they can manipulate them. A couple bones in every ear so they can be manipulated, and just rotated, and again, have them, hooked up so they can just be scaled and whatnot. So it's easy to control. And take a look at, where you need them, how to place them, what kind of poses need to be dealt with. And I think in this sort of system, you can actually generate a pretty good rig just with points. And again, make it fast and easy. Make sure that you've got some good scripts that are solving your ability to be able to make it quickly. And that's a big one there. A lot of times you can't get stuff into a rig because it's just the amount of time. Well, if you can simplify that and make it really fast and easy to build, like we've just done with this script, it can be very, very quick and easy to build together a bone-based facial rig or whatever with one simple tool that we've done. Just clicking on spots and laying them down and skinning into it. Make it very, very easy and quick to set up the next one as well. Of course, I've gone much further, and my tools allow me to be able to connect, add the all those list controllers by name, and actually wire them into the control objects based on their name and whatnot quickly as well. So I can actually hook up those sort of, we'll call them transform morphs into the control objects really fast and simple as well, and skip back and forward through them. So is there a controller for save poses for the face? Don't know what you mean. Sorry, David. Is there a controller for save poses for the face? So you want to be able to save an overall pose? Still don't follow you, David. The happy face, bad. Yeah, so you want to be able to save poses. You'd need some sort of pose saving tool. Not doing a plug or anything, but right here is Pose Saver. And what this allows you to be able to do is grab any tracks of anything anywhere and store poses on them and then scrub those tracks. I think is Pose Saver. No, he never got dumped on this guy. Pose Saver looks like this though. Here's Gwen from the same short basically, and if we look at her face, she's got the same sort of control object, but here's Pose Saver, and it's built into her, and essentially it's driving all of these controls, so it's saving data on these, and so we can easily go in and grab them and type in a GUR shape, for instance, or a scream, or a wink kiss, and the whole face. And then I've got the ability to be able to go in any one of these. So eyes closed, you can double click on them, drag on them, and you can save poses on the fly as you go, and just add them in however you want. So you can actually take a part-way shape any way along and save those. So Pose Saver can be a solution to you. I think there's other ones out there that are probably free and whatnot as well. I wouldn't be surprised. This one's worked well for production for me as I put it on clients' tools and whatnot. So can really sort of speed up that ability to save poses off. And again, it'll work on anything. I could do it all the shapes all around the mouth, as well as these control objects, and build groups of them. However, these groups are this is all customizable by the end user, through a UI here, and add tracks UI and everything. So it can be manipulated all in here, changing the names and everything and whatnot. So does that answer your question, David? Again, you'd have to write yourself some sort of tool, either that or use one that's already out there. So last couple of minutes, let's just do some more question and answer. Anything else? Why the controllers in your final mesh shows splines and some polys? Don't know what you mean. Are you looking at this model here we're looking at, David? In the monster? Which one? The one we rigged, or the other one, the full rig? These are all just spline objects for controls. They're all splines. Or are you talking about the one the one we did where you could see the dot? Oh, you mean on here when I was showing it, you could see those blue lines? Is that what you're asking? These rig, all these blue lines? Yeah, that's actually look-at constraints on bones that you're seeing. You just can't see the bones because the bones aren't actually bones. They're just, oh, what a mess. Kind of hard to see. It's actually the point helper. I'm skinning to the point helpers, to a set of point helpers that are above it, and each one of those has a look-at constraint. It's basically set up as a bone, as a stretchy bone. So instead of using bones, I'm just using point helpers to clean the rig up a little bit. And if you actually go into, it's actually not even a bone on, so I'm not even using them as bones. I don't even think I'm stretching them at this point. Have to check. You can make any object. You can make a camera a bone and act like that stretchy bone idea. It doesn't matter what it is. In Max, anything can be set up as a bone and become a bone in a sense, and have all the same properties. It wouldn't have the fins and everything, but it would have all the same properties. So in my case, I'm just skinning up to point helpers here. Again, I wouldn't go down this road. I did for this rig, and I kind of look at what we did for the other one. The way I'm doing it now and dealing with it. This is way cleaner. It's way simpler. It's way faster. It'll react faster in animation by a long shot than morph targets with attachment constraints, which all that kind of stuff. If you want them to sort of flow around with the face, and it'll still allow you to be able to build those morph target sort of solutions to driving them without having to work out a pile of crazy math. As if I push this one along the X and this along the Y, it's just a weight on a list controller. So it makes for a very, very fast and easy setup. You'll end up with a whole bunch of controllers in the list, but it doesn't tend to slow things down that much, just weighting up and down those end results. So